Welcome to week 2 of our course on analyzing and visualizing data with Power BI. Now that we've covered some of the basics in week 1, you should be comfortable with how Power BI Desktop and Power Query work together to retrieve and prepare data, create and load information into a data model, and give us tools to visualize that data. In this week's lessons, we will dive deeper into both of these topics, and we'll do it using some public data that provides us with a more global perspective than what we used in week 1. Specifically, we'll be using 50 years of economic data from the World Bank that gives us some fantastic learning material. We'll cover some new techniques in Power Query, such as how to merge different data sources together, and how to view and interpret data lineage diagrams. We'll also use DAX to create more advanced formulas, and we'll look at more methods of data visualization, such as Sparklines, conditional formatting, and combination charts. And finally, towards the end of the week, we'll pop open the hood on some Power BI components to see how they work. For users on the verified track, we'll also have some exclusive bonus content you can check out, like interviews with Power BI experts, a Power BI exercise that uses the Python programming language to visualize sports analytics data from the World Cup, and some tips and tricks that you'll hopefully find useful. Okay, let's get started on week 2. For the start of week 2, we're going to focus on a scenario that requires us to learn more about data modeling and creating measures in DAX. The dataset we're using comes from the World Bank's Data Bank, an online portal where you can access a treasure trove of publicly available data about the world we live in. If you're not familiar with the World Bank, it's an international financial institution based here in the United States in Washington, D.C., and established in 1944 with the mission to combat extreme poverty in the world by providing loans and grants to developing countries and non-governmental organizations. When I was studying international political economy as an undergraduate student, I read a lot about the World Bank and their efforts to fight poverty and increase global prosperity. Now, regardless of what you might think of the World Bank and how it performs its mission, one thing is for certain. Their databank is an outstanding online repository of public databases you can use with Power BI to analyze a variety of topics. My personal favorite is the World Development Indicators database, and that's where I extracted the data that we're going to use in the first half of week 2 of this course. I suggest you take some time to explore the databank yourself by going to databank.worldbank.org and look around at the different resources that are available. You might find some data that resonates with you either personally or professionally, and you might want to use that data for projects that you can then use to continue learning Power BI and demonstrate your skills when you apply for jobs. For this exercise, we're going to use a different data source than we used last week. The World Bank actually has a free public API that we can use to get data from. If you're not familiar, API stands for Application Programming Interface, and it refers to software that we can use to make two systems talk to each other. APIs are used for a variety of purposes in application development, including moving data between systems to keep them synchronized, or giving developers a resource they can use when they need to populate data into a graphical user interface. We interact with APIs through the internet by sending a request to what is known as an API endpoint, which is an address that acts as our doorway to the API. And any request that we send to an API endpoint is known as an API call. When developing in Power BI, it's not uncommon to work with API data, so I'm glad we have a scenario here where I can show you what it's like to extract data from a web API using Power Query. The World Bank actually has a large number of API endpoints, and many of them are public and free to use. Now, if for any reason you have trouble communicating with the API endpoint we're using in this video, I've included a backup option in the exercise files. Just use Power Query to get data from a JSON file. To use the Web API approach, let's go to Get Data and select the data source type named Web. This will open a window where we can type in the URL or Uniform Resource Locator for a web page, or in our case, an API endpoint. So I'm going to proceed by typing in the following: https://api.worldbank.org/country/all?format equals JSON &per_page equals 500. Then let's click OK. You may get asked at this point what authentication method you want to use. This is because many APIs have some method of authenticating and authorizing requests to ensure that the system or individual who is trying to reach the API actually has permission to use its data. Now, in our case, the World Bank API is public and free, so we're going to select the option for anonymous authentication, which is often used for public APIs. When Power Query opens, our query has been added, and we see a single column and a couple of rows in our data preview area. The first row, which says record, just contains some simple metadata about the records that were retrieved from the API. But the second row, which says list, is an expandable list of data. If we click on the list keyword, this will convert each list entry into its own row in a new table, and each row says record. If we click in the empty space on one of these rows next to the word record, Power Query is going to give us a little preview down in the bottom half, which gives us an idea of what the data looks like. Remember in week 1 when we talked about attribute value pairs in the context of pivoting and unpivoting data in Power Query? Well, what we see here is how Power Query represents an attribute value pair in this particular context. In this case, each of these records is what we call an array, and each array has several attribute value pairs that contain data about every country in the world today. If you're a developer who has worked with JSON data before, you can probably tell what this is. For those of you who aren't familiar with JSON, the abbreviation is JSON, and it stands for JavaScript Object Notation. JSON is a ubiquitous format for exchanging data between systems, and it's probably the most dominant format in use today because it's incredibly flexible. JSON works by arranging data into arrays, which act as collections of data, and into key value pairs or attribute value pairs, which you will remember from our week 1 videos when we were pivoting and unpivoting our US states data. Before we go further, let's actually take a peek at what JSON data looks like in its raw format. I'm going to go back to the source step of our query and copy our URL out of the formula bar. Then I'm going to paste the URL into my browser and hit enter so we can see what it looks like. As you can see, this returns a whole bunch of raw data in a not very readable format. So I'm going to click in here and use Control-A to select everything and Control-C to copy. And then I'm going to paste the data into this little program on my Windows machine called DevToys, which is a free download from Microsoft that has a bunch of tools that can be very helpful to software developers. One of these DevToys is called the JSON Formatter, which takes the raw text I just copied and formats it into a more human-readable style. At the top of the JSON, or JSON, is the first array, spanning from lines 2 to line 7. And this is the one that we saw in the first row of Power Query a moment ago. It just contains some metadata about what was returned from the API, including how many pages were returned, how many records are included on each page, and how many total records we received. If we go down below that, we begin our list of countries. Each country is contained in its own array, starting with a curly bracket and ending with another curly bracket. Our first country is Aruba, which runs from line 9 to line 36. And this array also contains other arrays nested underneath it that have additional data about, say, Aruba's region, which you can see in the array that runs from line 13 to line 17. We also have other attribute value pairs in here, such as Aruba's capital city and its longitude and latitude on lines 34 and 35. And we can scroll down through the rest of the JSON to see all of the other countries that the World Bank data gives us, such as Afghanistan and Angola and so forth. So this is what raw data looks like when it's transmitted through JSON. Now, the challenge that this presents for our course is that Power BI interprets data in a very rigid two-dimensional format. Data is stored and presented to us as tables, where each table has rows and columns, and the data is contained within those rows and columns. But clearly JSON doesn't function the same way. It uses these nested arrays to organize the data, and it uses attribute value pairs, like you see here, to store the data. So we have to use Power Query to transform the data we receive from the World Bank API into a format that we can use in Power BI. This kind of process, where we transform data from a format like JSON into a different format, is known as parsing. Specifically, we're going to parse this JSON into the format that we need. There are several different types of parsing we can do in Power Query, such as XML parsing, if you're familiar with XML formatted data. In fact, when we connected to our CSV files in week 1, we were performing CSV parsing. Today, we're going to do some JSON parsing. Let's go back to Power Query, and we're going to start by converting this data that we have into a table. This can be done on the ribbon by simply clicking the To Table button that you see in the upper left corner. Make sure that you are on the most recent step of the recipe when you do this, obviously. So we're going to click To Table. It's going to give us this little table where we can select delimiters and how to handle extra columns, but we can just select OK here to use the defaults. Then we're going to click this little expand button on the far right side of our column, and this is going to give us a list of all of the attributes that exist for each record. From this list, we are going to select the following attributes: ID, ISO 2 code, name, region, capital city, longitude, and latitude. Then click OK and watch as Power Query translates the attribute value pairs into a row and column structure. Now, we're not done yet because our region column, as you can see, still says record on every row. So we need to expand that nested array. So we're going to click the expand button to the right of that column header, and this time we're only going to select the column named value. Then click OK, and we can see that the value column contains our region names. And now let's go and let's just quickly rename that column to region so that we remember what it is. With that step, we have successfully parsed the JSON data that we received from the World Bank API, and we have produced a format that is suitable for Power BI development. Next, let's change our data types by switching these first several columns to text, highlighting ID, ISO 2 code, name, region, and capital city, then right-click, change type, and set to text. Then let's also make sure that our longitude and latitude columns are changed to decimal number data types. Lastly, we need to do a little bit of filtering. If you look closely at the data we received, it's not all just countries. There are some records in here that contain what the World Bank refers to as aggregates. These are collections of countries that the World Bank has pre-aggregated for us, but we don't need these for our analysis. So let's just right-click on one of these, then go to Text Filters, and select Does Not Equal. This will remove the aggregates from our table. And finally, let's go to the Properties settings here, and let's rename our query as just Countries. Now, let's examine the data for a moment. We have a table with a granularity of 1 row per country, with each row containing one unique country in the world. As for our columns, the ID column contains each country's 3-digit ISO abbreviation, and the ISO 2 code column contains each country's 2-digit ISO abbreviation. If you're not familiar, ISO is the International Organization for Standardization, based in Geneva, Switzerland. ISO works with its member countries to develop global standards in various technical and non-technical fields, such as engineering, computer programming languages, and even things like document management. Among those standards is the ISO 3166 standard, which is used to identify world countries, and which includes a series of abbreviations like the ones that you see here. These abbreviations are commonly used by national postal systems, internet domain name systems, international banking systems, and machine-readable passport systems. those abbreviations that are used by those various systems are what you see here. So after that, we have each country's name, followed by the region of the world that it belongs to according to the World Bank, and then its capital city. Finally, we have the longitude and latitude coordinates that should roughly equate to each country's geographic center. These columns give us some really interesting data points that we can play around with in our Week 2 lessons. Now, take a few minutes to use your column profiling features to take a look at each of these columns. And also, remember to use the Advanced Editor feature to review the Power Query M code that was generated by our JSON parsing operations. Before we end this video, let's bring in some data from another source. We have a CSV file in our exercise files that contains the numeric data we want to play with this week. So let's go to Home, then New Source, and select text/CSV. Find the file named Countries Indicators and load that into Power Query. Once it's done loading, make sure to click the button that says Use First Row as Headers to promote the first row of data into our column headers. This indicators query looks a lot less simple than our countries query. We can see that we have columns identifying each country name and country code to start with, and then we have indicator columns called series name and series code. But then we have dozens of columns along the horizontal axis stretching from here all the way out to the end. Looks familiar, right? This actually looks a lot like our population figures data from Week 1. So notice the granularity of the data in this particular query. We have 3 rows per country. And if we look closely at the third and fourth columns of the file, we can see that each country has a row for its GDP, or gross domestic product, its land area measured in square kilometers, and its total population. These are the 3 indicators that we will be analyzing over the next several videos. The challenge here is that all of these different indicators are all contained together in a single file. So we'll be using Power Query to explore some different methods for transforming the data from this particular source into a model that can be used in Power BI. Our goal over these next several videos is to use these indicators to examine population density across the globe, as well as economic growth and prosperity. And as you can see by all these columns that contain yearly data, we'll be analyzing this data over a period of 50 years. This is going to allow me to teach you some fantastic topics around data preparation, modeling table relationships, writing measures in DAX, and how to create rich interactive reports. The next step we need to take in Power Query is to restructure our indicators data, which is currently arranged in a pivoted style, much like the population figures that we used in our Week 1 exercise. We have 50 years worth of indicators from the World Bank that we need to unpivot so we can use DAX to write measures and efficiently visualize this data in Power BI Desktop. The challenge this particular table presents to us is that we have 3 different indicators all intermingled together in the same file. But truthfully, for DAX this is not a problem. With a well-built data model and a few measures, we can easily handle this situation. Before we go further, if you carefully reviewed the indicators file, you noticed that there are 5 rows at the bottom of the file below our main data table that contain some metadata about the file, including which World Bank database the data came from and when the underlying data in the database was last updated. We don't need this information in our report, and the 3 rows above that are all blank. Now, thankfully, we can remove these rows using a little feature on our Home tab. If we go to this little section called Reduce Rows, there's an option to remove rows, and we can say Remove Bottom Rows, and just put in the number 5 and hit OK. And once we've done that and scroll back to the bottom of the data, we can see those 5 rows are now gone, and we are left with just our indicators data for each country, starting with Afghanistan and ending with Zimbabwe. Next, our indicators data does not need to contain the country column. That column already exists on our countries table, as you can see here, so we can go back to countries indicators, right-click on country name, and then remove it. You should now just have the 3-digit country code, then the indicator code and indicator name, or series name and series code in this case, followed by the 50 columns that contain our yearly figures. Now let's unpivot the data. This is going to look a lot like the unpivoting that we did in week 1. We're going to select our first 3 columns in the table, then we're going to right-click and select Unpivot Other Columns. This will unpivot the columns that have the yearly figures. In the resulting table, let's take a moment to note the granularity. We seem to have created a table that is 1 row per country, per indicator, per year. With 50 years of data and 3 different indicators, our resulting table is going to be 150 rows per country, which for this particular data source from the World Bank, with over 200 countries, should give us somewhere in the neighborhood of 32,000 rows in our final table. Now, the next thing we need to do is clean up our results. Notice how the data in our column, which contains all of the years, has this extra text in brackets. We can remove this from our column by going to the Transform tab, finding the section for Text Column Transformations, opening the Extract menu, and then selecting the option to extract first characters. When the window opens, input the number 4 and click OK. This will extract the first 4 characters from that column, giving us only the numeric value of the year, which is all we need, and stripping out that extra text that we didn't need. Also notice how some countries don't have data for certain years. Like Afghanistan here doesn't have any GDP data prior to 2002. You'll find that these little placeholder values in here, which are just 2 periods, exist in dozens if not hundreds of these cells. The rest of the data in this column is numeric, but these placeholders are text, so if we try to change the data type on this column to numeric, all of these placeholders will become errors in the data, like so. We don't want that to happen, so ideally what we should do here is remove the placeholders. So I'm going to undo that step I just did. And to fix this, we can do one of 2 things. We can either replace these placeholder values with blank values, or we can just filter them out entirely. Either technique, replacing or filtering, will work fine for our purposes. But remember that I am usually of the mindset that we should bring in the minimum amount of data that we need for our report. So I think it makes the most sense to remove these placeholders entirely by filtering them out through Power Query instead of loading a bunch of empty rows into our data set. So I'm going to right-click on one of these placeholder values, then use text filters and the option that says does not equal to remove all rows that contain the placeholder value. Next, let's go through and rename our columns and check data types to make sure they are correct. I'm going to change the attribute column to year and the value column to indicator value. The first 3 columns should all be text, and they are, so that's good, but we will change the year column to a whole number, and we'll change the indicator value column to a decimal number. Now, make sure to turn on your column profiling features and review each column for any errors. If you followed the steps I took, you should end up with 5 columns in your final indicators table, and each column should contain 100% valid data. There should not be any errors or empty cells. Finally, let's take a moment to review the Power Query M code that has been generated using the advanced editor. We ran our data through several steps in this recipe, but the only thing we did this time that was different from what we really did before is we employed on line 6 this table.removeLastN function to remove those bottom 5 rows that had that extra metadata in them. Otherwise, we ran through our usual recipe of removing data that we don't need by eliminating columns and filtering rows, then changing our data types and renaming our columns, not necessarily in that order. Now, one additional step that we can take before going into Power BI Desktop is to build our measures table. So let's go ahead and do that. On the Home tab, click the Enter Data button, And then let's do the exact same thing we did in week 1. We're going to add an empty column with a simple placeholder name. In this case, I'm just going to use a dash. And then we'll name the column underscore measures. Then click OK. This adds the empty table to our data model ahead of time, and it illustrates the fact that there are some operations that you can perform in both the Power Query Editor and in Power BI Desktop. One interesting aspect of the indicators data that we have been looking at is the land area indicator, which you can see here. Land area is a simple measurement of a country's total area measured in square kilometers, but excluding any area that's under inland bodies of water, such as rivers and lakes. A country's land area does sometimes change, as borders between nations shift, as rivers slowly change course through geomorphological or man-made causes, as lakes dry up. These are all factors that can cause land area to change from year to year. However, for the most part, the land area of each country should be relatively steady. So our goal in these next few videos is to use Power Query to get the latest land area for each country from our indicators table, and then add it to our countries table using a process known as merging queries. When we merge queries, we can link two tables using one or more columns that they have in common, and then combine their data together into a single table. The ability to combine data from multiple tables using the Merge Queries feature in Power Query is a foundational skill for Power BI developers to learn, especially when you are potentially working with data that comes from multiple sources. To get to the point where we can merge the queries together, though, we need to talk about a couple other useful Power Query techniques, namely referencing queries and duplicating queries. The data we're looking for comes from the indicators table that we already imported. The challenge here is that we want to keep the yearly values for GDP and population so that we can look at those indicators over time in our report. We want to be able to look at GDP and population on a yearly basis. On the other hand, with our land area, we only need the most recent indicator for each country. So we need to find a way to split up the indicators data so that we can get our GDP and population figures in one table, and then get our land area figures in a different table. So first, let's go to our indicators query, and let's rename it as source indicators. This is just going to tell us that this particular query came directly from the data source, our CSV file, and this will be helpful later on down the road. Then let's right-click that query, and we're going to turn off the Enable Load option. When a query has been disabled in Power Query, its name will show up in italics in the left-hand Queries panel. This means that the results of the query will not be loaded into Power BI Desktop when we load our data model. However, that doesn't mean that the query itself is not still useful to us. Disabled queries can still be used in Power Query as a way to prepare data that goes into the final model. Next, let's right-click on the Source Indicators query and find the option for Reference. The reference query function creates a new query in the Power Query Editor using the output of the query it references. And this is where it's really helpful to think of queries in Power Query as a linear sequence of processes. Power Query will perform whatever transformations you tell it to against the original query first. Then it will take the output created by the original query and use that as the source of the new query. So whatever changes you make in the first query will automatically flow from the output of that query to the input of the second query. So let's demonstrate. Click on Reference, and we'll see a new query appears in our queries list called Source Indicators 2. If we open that query, we see that it only has one step in its recipe called source, and the Power Query M code for that source step just refers to the name of our original Source Indicators query. Now, let's update our recipe by filtering down to just the land areas indicator. open the filters control for the series code column and find the AG land total K2 value. Unselect all the others, select this one, and then click OK. This takes the output of our source step and filters it down to just our land area figures. Now let's further narrow the scope of this data by filtering the year column on just the year 2020. I'm going to find the first row with the year 2020, right-click, go to Number Filters, and select the Equals option. Finally, remove any extra columns that we don't need, such as series name, series code, and year, and then right-click and remove columns. Then we will rename the indicator value column as land area. The result is a table that is one row per country and only contains the land area figures for each country from the year 2020. Now let's try something that's related to the reference function we just learned, and that is our duplicate query function. When we right-click on our query, you'll see that duplicate and reference are located right next to each other on the menu. But they perform totally different functions. Whereas reference will create a second query that references the output of the first query, the duplicate function will literally recreate the first query step for step. So if we were to duplicate our source indicators query, it would create a brand new query that connects to the same CSV file data source and performs the same transformations right down to the unpivot. It would not, however, duplicate any of the queries that reference our source indicators query. It only duplicates one query at a time. So, how can the duplicate function be useful to us here? I'll show you. You can actually duplicate the reference table that we just created, the one where we filtered on land area. This adds another table to our queries list called source indicators 3. And then let's simply go to the recipe of that query and let's change the filter criteria. First of all, we're going to delete the step where we renamed columns, delete where we removed columns, and then we're also going to delete the step where we filtered on the year 2020. Then let's edit the step where we filtered on the land area indicator, and instead of filtering for land area using an equals operator, we're actually going to filter against. So we're going to actually try to exclude land area by using the does not equal operator. Then click OK. And what we get is a table with one row per indicator per year, but only containing the GDP and population indicators. Land area is no longer in this table. Finally, let's do some quick renaming of our queries. Change source indicators 3 to just indicators. And then let's go to source indicators 2, and we're going to call this land area by country 2020 in parentheses. Now let's reflect on what we've actually accomplished here, because it might not seem obvious at first glance. By using the reference function, we effectively took the output of the original source indicators query and split it off into two brand new tables, each with its own separate set of data. I like to think of processes like this in terms of upstream queries and downstream queries, and these terms are very commonly used when talking to data professionals. In this case, the source indicators query is our upstream query, and our new queries are the downstream queries. Remembering that Power Query processes data in a very linear fashion, if you think of the data as flowing through these recipes like a river or a stream from left to right, then we started upstream with our source indicators query. Then we came to a fork in the river, and we funneled our land area data down one stream, and we funneled our GDP and population data down a different stream. So we think of these queries that we created using our reference and duplicate functions here as being the downstream queries, and sometimes doing certain data transformations against the upstream query can create more efficiency in Power Query. Think of it this way. We needed to unpivot our indicators data in our last video. To accomplish that, we added the unpivot operation on the upstream query, so we only need to do it once. If we had instead chosen to do it on our downstream queries, that would not have been as efficient, because first we would be splitting the data into two separate queries, and then we would be performing the same operation in parallel against each of those queries. Choices like that can have a performance impact in Power Query because it takes processing power and memory to do these kinds of operations. Now, the volume of data that we're working with in this particular exercise is not nearly big enough to create a noticeable performance impact if we had chosen the more inefficient method of doing those transformations on the downstream queries. But with a big enough data set, making choices like this can noticeably degrade the time it takes Power Query to do its work, which means it will take longer for your Power BI datasets to refresh. So, by applying that unpivot transformation to the single upstream query, we consolidated the logic of that transformation in one place, and that hopefully can improve the performance of our operations in Power Query and lessen the amount of time it takes to refresh the dataset. Not only that, but consolidating business logic like that can make your Power Query easier to understand, either for you or for other developers who come after you. And if you need to update that logic in the future, you can update it in the upstream query, and those results will automatically flow down to the downstream queries. Now, this can be both a blessing and a curse if you don't know what you're doing. If you apply a transformation to the upstream query not knowing that it will affect all of the downstream queries, you could inadvertently mess up your Power BI project. So study carefully the distinction between referencing a query and duplicating a query, and know when you should use one technique instead of the other. The ability to reference queries in Power Query is a great skill to learn. If you have a set of transformations that need to be applied across multiple tables, you can perform those operations in an upstream query and then use the reference function to split the results of those transformations as needed. The downstream tables then benefit from having those operations performed in one place, in the upstream query, instead of requiring you to duplicate those operations across 2, 3, or however many downstream queries. This technique can help you create more efficient processes when you are building your data engineering recipes in Power Query. Okay, let's break here, and in our next video, we'll show you how to merge queries. In our last video, we used the reference queries and duplicate queries functionality in Power Query to take our original source indicators query and split it into two different downstream queries named Land Area by Country 2020 and Indicators. The Indicators query is one of the tables that will ultimately end up in our model in Power BI Desktop. In this video, we're going to finalize the Countries table that will also end up in our data model. First, let's make sure that we have selected our countries query in the queries panel on the left-hand side. Generally, you want to try to start from whichever query is the main query when you're about to merge two queries together. Our goal here is to supplement our countries table by adding land area to it. So I'm treating the countries query as my main table in this operation. Next, I'm going to go to the Home tab on the ribbon, and I'm going to left-click on the menu that says Merge Queries. This is going to present me with two options, Merge Queries and Merge Queries as New. I like to use the Merge Queries as New option because it can make the whole merge process a lot less confusing when you're working with many tables. It also works better for diagramming the flow of the queries in Power Query, which I'll show you in a moment. So select Merge Queries as New, and a window will appear with an upper half and a lower half. The upper half is the main table that you're starting with, in this case our countries query. And the lower half is where we will select our second query, so we can combine them together into a single table. So, using the second drop-down menu, select the Land Area by Country query from the list, and watch how this window now gives us a preview of the data in that table. At this point, we need to select which column or columns we want to use to merge the data together. Using Control-Click, you can select multiple columns in each table in sequential order, but we only need one column for this lesson, so I'm just going to left-click to select each one. And if you guessed that we want to use the column with the 3-digit country code, you are exactly correct. So in each of the data preview windows, left-click to select that column. Now, one thing that you notice here is that we're combining data from two different sources, so Power Query may prompt you to select the privacy level that you want to use for one or more of these data sources. If you see this window pop up, you can tell it to ignore privacy levels for this file. In this case, we are using publicly available data, so we don't need to worry about combining data that comes from different internal sources. We're using public data, and we can just use ignore privacy levels to say this is public data, so we don't need to worry about this. Hit save, and now notice how Power Query has displayed a message at the bottom of the window that tells us how many records it was able to match between the two tables. Specifically, it says it was only able to match 215 out of 218 rows from the first table, which is our countries table. This means there are 3 rows in our countries table that Power Query could not find matches for in our land area table. And that's fine, sometimes that happens. Let's keep going because soon it will become clear why we were not able to match all of those records. The other thing to notice before we close this window is the Join Kind drop-down menu. Join kinds are also commonly referred to as join types, and you can see we have 6 different ones we can choose from here, and the left outer join is the default option. Those of you like me who practically live inside of SQL databases should recognize all of these options. Power Query gives us a brief description of what each join kind does, but I'll use our next video to demonstrate them. For now, let's wrap up our table merge by clicking the OK button. When we go back to the data preview, we see a new column has been added with the name of our other table, land area, in the column header, and each row has the word table in it. This indicates that there is joined data that we can now add to our countries query. To add that data, we just need to click on the expand button, similar to what we did when we were parsing the JSON in our first video. This will open a small window which asks us which columns from the table we want to add. Let's actually select both columns, and for now let's keep this little option enabled that asks us whether we want to use the original column name as the prefix. This will help us distinguish the columns that come from the countries table versus the columns that come from the land area table, as you can see here, where both of the columns that come from the land area table have that little prefix added to them. This is a merge queries operation in action. We now have data from 2 separate data sources combined into a single output table using the 3-digit country code as the common identifier between those 2 tables. Now, why were 3 rows of our countries table not able to be matched? If we sort or filter on the null values in our 2 tables, we might get an idea. So let's scroll down and we find our first null value, and then let's right-click on that, go to Text Filters, and select Equals. We can now see that the 3 unmatched countries or territories are the Channel Islands, which sit off the coast of Normandy between France and England, the island of Taiwan off the coast of China, and the nation of Kosovo in the Balkans. The Channel Islands are kind of weird because they don't officially fall under the government of the United Kingdom. In fact, they are self-governing, but are considered to be possessions of the English monarchy. Kosovo, meanwhile, has only partial diplomatic recognition. Since Kosovo declared their independence from Serbia in 2008, only about 100 United Nations member states have officially recognized them as a sovereign state. Kosovo's diplomatic status today remains a point of contention between many states, with Serbia and the Russian Federation in particular being staunchly opposed to recognizing Kosovo's independence. And the same can be said of Taiwan, which today represents one of this world's most potentially dangerous political flashpoints. Split off from China when Chiang Kai-shek fled the onslaught of Mao Zedong's Communist Revolution in 1949, Taiwan has been autonomous from China ever since and has maintained informal diplomatic relations with much of the rest of the world. Over the past several decades, Taiwan has flourished into a global technological powerhouse, and it's especially known these days as being one of the world's foremost producers of semiconductors. It is universally considered to be one of the world's most advanced economies. However, Taiwan's existence today remains an enormously thorny issue in international relations, as China has refused to acknowledge Taiwan as a sovereign state and maintains an official policy of, quote, Chinese unification, which means the communist government fully expects the eventual absorption of Taiwan back into the Chinese state. As a result, nations afraid of angering China have been delicately trying to tiptoe around the Taiwan issue for decades, but tensions have risen significantly in recent years. We can only hope that all sides can eventually come to a mutually agreeable diplomatic resolution. But anyways, I digress. Let's move on. This is a course about Power BI, not about Taiwan. So in all three of these instances where we weren't able to match data between our two tables, we're looking at countries or territories that reside in an interesting gray area where they each lack a certain amount of diplomatic recognition. As a result, it seems the World Bank hasn't been collecting their indicators data, so we don't have any data for them that we can use for this particular analysis. We will need to exclude them. So what I'm going to do is I'm going to back out our filtered rows step, and in our next video, we will talk about the different kind of joins that we can use when merging tables in Power Query, and we will deal with our unmatched records here. In our last video, we used the merge queries as new operation to merge our countries and land area tables into a new query, which is named merge1 at the moment. In the process, we briefly mentioned the join kind menu that goes with our merge queries operation. Let's do a deeper dive into the different join kinds that we can perform in Power Query. It is common to use overlapping circles like a Venn diagram to illustrate the various types of joins that you can make between tables in relational data situations like this. So we'll add some diagrams to this video, which should help you understand if this is your first time hearing about join types, and then I'll demonstrate each join type using our country's data. Now, remember from our last video that the left outer join is the default join type and is arguably the most commonly used join type. If we think in terms of the countries table being our left-hand table and land area being our right-hand table, a left outer join will return all rows from the countries table and will only return matching rows from the land area table. Now, we can tell that what we have here is a left outer join because as we scroll down the table here, we can see that all 218 rows from our countries table are still present, but there are 3 rows that are empty for the territories of Taiwan, Kosovo, and the Channel Islands. So our left outer join returned all rows from the countries table, but returned only the rows that match from the land area table. The empty rows, like the one that you can see here for Taiwan, are the ones that were unmatched. So let's go through the list and illustrate the other join kinds. A right outer join is the opposite of a left outer join. It will return all rows from the second or right-hand table, but will only return matching rows from the left-hand table. On our merge1 query, if we go back to step 1 in our recipe and use the gear icon to open up the settings again, we can change this from a left outer join to a right outer join. Power Query now tells us that this was able to match 215 out of 215 rows from our right-hand table. So we successfully matched 100% of the rows in this right outer join operation. And if we click OK and go back to our query and scroll down, we are left with 215 rows. So this shows a 100% successful match of the right-hand data to the left-hand data. Next, a full outer join will return all rows from both tables, even when there are no matches. So if we again go back to step 1 and click on the gear icon and change our right outer join to a full outer join, Power Query will tell us how many rows it was able to match. In this case, if we hover over, we can see that the selection matches 215 of 218 rows from the first table and 215 of 215 rows from the second table. If we click OK and apply this and then go back to step 2 of our recipe, we can then scroll down and we can see the empty rows for the Channel Islands and Taiwan and Kosovo. If we scroll all the way to the bottom, we won't see anything else because there were no unmatched rows from the right-hand table. So we still have 218 rows total. So in essence, a full outer join in this particular circumstance just gave us the exact same result as a left outer join. But if there had been any unmatched rows in the land area table, those would appear down here at the bottom of our query. Next, we'll demonstrate the inner join, which is similar to a left outer join or a right outer join, except in this case, an inner join will return only the rows that have matches in both tables. So if our left outer join returned all 218 rows from the countries table, but only 215 of those rows had matching data from the land area table, an inner join sort of takes that a step further because it will return only the 215 rows that matched across both tables. In other words, an inner join will return only data that exists in both tables. So if we go back to step 1 and open the settings and change this from full outer to inner, and then click OK to complete the merge, and then return to step 2, and scroll down, we can see that we're left with 215 rows, and we don't have any rows that have empty data. So we have returned only the data that matched across both tables, which is great. Now, the last two join kinds that we will demonstrate are called anti-joins, which means they will return records that do not exist in one table or the other. Let's demonstrate. A left anti-join will return rows that only exist in the first or left-hand table. In other words, it purposefully returns only the unmatched rows from our countries table. So if we go back to step 1 and select the left anti-join from our menu, Power Query tells us that this join will exclude 215 out of 218 rows from our countries table. So a left anti-join should return only 3 rows for us. Let's click OK and see the results, and click on step 2, and we can see that we only have 3 rows from our countries table, filtered down to only those countries or territories that did not have any matching data in the land area table: Taiwan, Kosovo, and the Channel Islands. Lastly, the right anti-join will return rows that only exist in the second or right-hand table. To put that differently, the right anti-join will give us any unmatched rows from our land area table. Of course, if you recall, there were no unmatched rows from our land area table. We've seen this consistently with our full outer join, right outer join queries. So this should return 0 results. To test this, let's go back to step 1, open up the settings again, select right anti-join from our menu, and then it tells us it will exclude 215 out of 215 rows from the second table. So we can pretty much tell that we're not going to get anything. Let's click OK, and 100% of the rows have been excluded. Nothing is returned. So we can see 0 rows here. So a right anti-join doesn't give us anything to look at. So that was a walkthrough of the various join kinds or join types that you can use in Power Query. I can confidently say that for the vast majority of the time that you're developing in Power BI, you're probably going to rely mostly on the left outer join or the inner join kinds. I expect that we will use the left outer join consistently throughout this course, but it's still important to know the other join kinds because you could be tested on them when you try to get your Power BI certification. Not only that, these join types that we just went over are pervasive throughout the world of business intelligence and analytics. You will find them in SQL or SQL queries on top of relational databases, and you'll find them in Power BI's competitor platforms, such as Tableau. So being fluent in the various join types will prepare you for any eventuality that comes your way in the often unpredictable world of analyzing data. Before we move on to our next video, make sure that you go back to the step 1 of our merge one query and change it from right anti-join back to a left outer join and click OK. Then return to step 2 so you can see all 218 rows plus the 3 unmatched rows. And then I'll see you in the next video. After the little detour that we just took to talk about join kinds and Power Query, we need to get back on track. First, let's go to our merge one query and make sure that we've changed our merged operation on step 1 of our recipe back to a left outer join. That looks good. And then go to step 2 and make sure that we're getting the columns from the land area table added to our query. The country code column that we added here is redundant because we already have it in the ID column on the left-hand side of our query. So let's modify step 2 and remove that extra column. And while we're here, let's also remove the column name prefix from this little box at the bottom because that will shorten the name of our land area column. Finally, we don't need the unmatched rows from our second table. We just need the rows that match from both tables. So can you guess what we can do to accomplish that? Well, there are 2 possibilities. We can add a filter step to our recipe here and remove the null values from our land area column, like so. And when we scroll down, we can see that we are left with 215 rows. So that technique works well. Or the other thing we could do is remove that filter step, go back to step 1, and edit our join kind and change it to an inner join. If you do that and go back to step 2, you will see that we also have 215 rows. So both ways are correct. If you do an inner join, you will get the exact same number of rows in your result as you will if you use a left outer join with an additional step to filter out the null values. Doesn't really matter. They both accomplish the same output. So regardless of which path you took, you should now have 215 rows, as I do here. And you should also have 8 columns, each country's ISO 3 and ISO 2 codes, its name, region, capital city, longitude and latitude, and land area. Now let's take a few minutes to talk about query dependencies and lineage. Over the last few videos, we split one upstream query into 2 downstream queries. I'm referring, of course, to our source indicators query being split into the land area and indicators queries, using our reference queries and duplicate queries functions. We then merged 2 queries together to build a completely new query. Namely, we took our countries query and our land area query, and we used the merge queries as new function to combine them and produce a totally new query, which so far is just called merge one. Along the way in these videos, you probably noticed I was occasionally displaying a diagram view that gave us a graphical representation of our tables as we were splitting them and merging them together. We can see this in Power Query if we go to the View tab and click the option named Query Dependencies. This opens a new window which gives us a diagram that illustrates the flow of data from our data sources into the various queries that you can see on the left-hand panel of the Power Query editor. This Query Dependencies window is resizable by clicking and dragging its edges like so, and you can then change the layout of the diagram using the menu at the bottom edge of the window. I'm going to change this into a left to right layout, and it should automatically resize. You can click the Fit to Screen button here to resize if you want to kind of make it a little bit bigger and easier to see. Let's start on the left-hand side of the window and work our way to the right. First of all, you see our measures table, which we created a few videos ago, but which is empty. But you can also see these two black boxes, and if we hover over each one, we'll see that the first is the address for our API endpoint that we called in our first video, and the second is the local path for the CSV file that contains our indicators from our week 2 exercise files. So each of these boxes represents one of our data sources, and each one has an arrow that points to the next stage of our process. As we trace these arrows from left to right, we can see where the source indicators query was split into two separate downstream queries, our land area by country 2020 query and our indicators query. We can also see where our countries query was then merged with the land area query to create our new merge one table on the far right side of the diagram, which will also end up in the final data model after we rename it. Now, later in 2023, a new view will become available in Power Query Editor, which is known as the diagram view. It's like a much fancier version of this query dependencies view that you can see in front of you, and you'll be able to see changes to your queries happening in real time, quote unquote, as you add transformations and merges and other operations in Power Query. Regardless of which view you use, you can get a very informative understanding of the progression that your data goes through as it begins its journey at the data source and then gets processed through your data recipes and ultimately ends up in your model. Let's take a moment to load what we currently have into Power BI Desktop. Let's click Close and Apply and load our existing query results into our Power BI dataset. Once it's done loading, we'll see that Power Query loaded 5 different tables. It created the empty measures table, and it also loaded our merge one table and our indicators table, alongside the original countries and land area by country tables that were used to build the merge one table. These tables, land area by country and countries, are not needed in our model. The merge one table that we have here actually supersedes them, so we need to find a way to actually remove them from our data model. So how can we do that? We need to return to Power Query. We're going to hit the Transform Data button to reopen the Power Query Editor, and then on the left-hand panel of the Power Query Editor, I want you to find the countries query and the area query and right-click on each one and unselect the option that says Enable Load. You will get a warning that says possible data loss, but you can ignore this. As you can remember from when we did this exact same operation to our source indicators query a few videos ago, this will disable the loading of these two queries into our Power BI data model. However, this does not affect their ability to generate the merge one table. By disabling these queries, we simply disable them from being loaded into the final model, but they're still being used by Power Query before the final model to prepare our data. And if we go back to the query dependencies view, we can see that both of these tables, land area by country and countries, both say load disabled, while the other tables, indicators and merge one, say loaded. This is what we want. So let's take a few moments now to quickly wrap up our Power Query steps. First of all, let's take our disabled queries and let's rename them. I'm going to put the word source before each of their names. I'm putting source before each name so that we know it's being used as a source for our merged or split queries. Then I'm going to go to our merge one query and I'm going to rename this one as countries. At this point, we are finally ready to load the data into our model. I'm going to go back to Home, hit Close and Apply. And when it's done loading, we can see that we have countries and indicators only. We can now create a relationship between these two tables by dragging the ID column from the countries table onto the country code column of our indicators table. This will create a one-to-many relationship from the countries table to the indicators table. Over the last several videos, we covered a lot of methods for connecting to data and preparing it in Power Query. We showed you how to connect to a web API, how to parse JSON data, how to reference and duplicate queries, and how to merge different queries together. Now, over the next several videos, we'll model that data in Power BI Desktop using DAX, and we will start building our report. After our data model is done loading, let's review both the data view and the model view to make sure everything looks the way we expect it to. In the data view, our countries table should have 215 rows and 8 columns, with 1 row per country. And our indicators table should have roughly 19,000 rows and 5 columns, with a granularity of 1 row per country per indicator per year. Our two indicators, being total population and gross domestic product, or GDP, can be seen if you open up either the series name or series code columns. Now, one thing to observe about the GDP figures is that they are being measured in constant 2015 prices expressed in US dollars. This means that, in the process of collecting this data, the World Bank converted each country's domestic currency to US dollars using the official exchange rate in 2015. Using a reference year like 2015 not only helps us to account for monetary phenomena like inflation and deflation that occur over time, but it also helps us to rescale each country's GDP to obtain comparable and consistent measurements when you consider the fact that most countries differ in how they implement monetary policies, and different currencies have different relative values. So hopefully that helps you understand, at least a little bit, why we're using constant 2015 US dollars. In short, it gives us a consistent frame of reference for the data that we're about to work with. Now, on the model view, we should have a one-to-many relationship from our countries table to our indicators table. If a one-to-many relationship does not already exist because it was not automatically created by Power BI, you can create one manually by clicking and dragging the ID column from the countries table onto the country code column on our indicators table. So this data model looks very similar to the model from our US states report in week 1. We simply have more data with a more global focus, and we have two different indicators we can look at. Now, both of our indicators are mixed together in the same table, as we can see from our data view. Our goal in this video is to define a series of measures with DAX that allow us to analyze the indicators stored in this table separately from each other. Let's start with the basics. We imported two indicators into our dataset, population and gross domestic product, or GDP. We will want to define a separate measure for each one so we can plot them separately in our report. And this part will be really easy. We're just going to use the sum function in DAX to sum the totals for our indicator value column, which you see here. But we're going to combine that with the calculate function that you will remember from week 1, so we can filter the indicators table on each indicator. Specifically, we will use the series code column that you see here. First, let's create a basic measure that sums the indicator value column on our indicators table. We will call it sum indicator value, all one word, equals, and I'm going to come down a line, open up a sum operator, and I'm going to sum the indicator value column as seen here. Close parentheses, and then commit that formula. That's going to add the sum indicator value measure to our model, and I'm going to use the home table drop down here to move that to our measures table. This simple calculation will serve as the basis for all the other measures in our model. We won't actually visually plot it anywhere in the report because this measure is currently summing all of the data from that indicator value column. That means it's summing population and GDP together, so we would get meaningless results in our report if we dropped this into a table or a chart. Rather, in the next couple of measures we define, we will need to use the calculate function that we've been using previously to change the evaluation context for our measure, forcing it to point at each of the other indicators. So with that in mind, let's go to the model view for a moment, and let's actually make our sum indicator value measure invisible in our model by clicking the eyeball button next to its name. We're doing this so that we don't accidentally add this measure to our report anywhere. Now let's start defining each of the downstream measures that we want to base on that indicator value measure. We'll start with population. I'm going to select the measures table and click New Measure. And the series code for population is sp.pop.totl. So I'm going to create a measure called population equals, come down a line, calculate, come down another line, and we're going to reference our sum indicator value measure, comma, come down another line, and now we're going to reference our series code column and say series code equals sp.pop.totl. Come down another line, close parenthesis, and commit our measure. Then let's go to our measure tools, which we can get to on the data view. Select our population measure, go to measure tools, and make sure that this is formatted as a whole number with commas. Then let's move on to our gross domestic product measure by again going to our measures table, clicking new measure, and the series code for gross domestic product is ny.gdp.mktp.kd. So we're going to create our new measure as GDP equals, calculate, come down a line. Once again, we're going to reference that sum indicator value measure that we created earlier, add a comma, come down another line, reference the series code column again, and then we're going to say equals ny.gdp.mktp.kd, come down another line, close parenthesis, and commit this value. Then let's make sure that this particular measure is formatted as a currency measure, and let's tell it to use 0 decimal places, like so. These measures, GDP and population, are both identical, as you can see, except for the fact that we're using the calculate function on each one to choose a different series code. So even though these rows of data are all mixed together in our indicators table, we can split them out into separate measures, so to speak, by using the calculate function. Next, let's add a fourth measure to our model that combines the two measures we just created. We're going to calculate GDP per capita, which is commonly used to measure economic prosperity. And this is done using a simple divide formula. We will say GDP per capita equals divide GDP measure, comma, population measure, comma, 0. So this is just like the divide formula that we used in week 1. We will then commit that, and we will make sure that this measure is again formatted as currency, and we will round it off to 0 decimal places. Next, let's add a few more measures that will calculate just some indicators for the year 2020. We're doing this so we can summarize the latest data for each country on the first page of our report. Our indicators data technically goes to the year 2021, but there are some gaps in the data collection for the year 2021, and I'd rather work with more complete data. So we will backtrack 1 year and use 2020 instead. And to accomplish this, we'll simply use our trusty calculate function to filter our GDP and population measures on the year 2020, like so. First measure, we will call this 2020 GDP. We're going to say this equals calculate GDP, comma, where the year from the indicators table is equal to 2020, close parenthesis, and commit. Then we will define another measure called 2020 population, which is equal to calculate population measure, comma, indicators year is equal to 2020, close parenthesis. And finally, we will define the 2020 GDP per capita, which is equal to calculate GDP per capita, where the indicators year is equal to 2020. Now let's go through and make sure that each of these are formatted correctly. 2020 GDP and 2020 GDP per capita both need to be currency measures, rounded to 0 decimal places. Like so. And the 2020 population will need to be a whole number, and we'll add some comma separators between our thousands. Okay. The final measure that we'll add in this video is population density, which is simply a measurement of a country's population divided by its available land area. We want to make sure we're measuring population density at a single point in time, so what we'll do is divide the 2020 population measure by the land area column from our countries table. We will call this 2020 pop density equals, we'll divide the 2020 population measure. Now you may have trouble entering this because the 2020 population measure name starts with a number, 2020. So if you have trouble with that, just simply start with a square bracket and then start typing in the name of the measure. You'll get 2020 population, then comma, and then for the denominator of our divide operation here, we will say sum of the area, land area column, like so, close parenthesis to close out our sum function, and then comma, 0 for our alternate result, then close parenthesis, and commit. Make sure this particular measure is formatted as a decimal number. And let's display for this one just one decimal place. Now that we've added all these measures to our measures table, go back to the model view and take a moment to look at them. And there's one more measure that we'll want to add to our model, but we're going to spread that out over the next couple of videos so I can teach you some DAX techniques that I think you should know. In this video, we're going to add one more measure to our economic indicators data model, but we're going to do it by using some particular techniques for writing DAX that I think everyone should know. Specifically, in this exercise, we need to calculate the GDP growth rate for each of our countries. To do this, we're going to create an annual rate so that for each year in our data set, we can see how much each country's GDP grew compared to the previous year. This is not a complicated calculation, but it's complicated enough that we can use it to illustrate these DAX techniques in a way that should make them easy to understand. When DAX formulas start to get more complicated, sometimes it helps to break them down into components. We did a variation of this in week 1 when we built our population growth measure. We created separate measures that calculated the population totals between 2 years, and then we referenced those measures in our final measure that returned the growth rate. However, it isn't necessary to follow that particular approach. Creating separate measures is useful if you plan to use each of those measures elsewhere in your model, or if you want to visualize them somewhere in your report. But if those measures are purely used for calculation purposes in one place, they might just be cluttering up your data model, adding measures to your measure table that you don't really need to be there. Instead, you can perform these calculations inside of a single measure, combine them together, and then return the result. This is known as using variables in DAX. Now, before we begin, recall our growth rate formula. We need to take the current GDP and subtract the previous year's GDP. Then we take that difference and divide that by the previous year GDP, which gives us a percentage growth rate from the previous year to the current year. So we'll go to Home and create new measure. Now, to create variables in DAX, you need to start on a new line and use the keyword var, or VAR. Then give the variable a name and an equal sign, and after the equal sign, you will write the calculation. And remember from our earlier lessons that to go down a line inside the formula bar, all you need to do is hit Control-Enter. So I'm going to start by creating a variable named current year, then set the equal sign. And this current year variable is going to use the selected value function in DAX to simply return the selected year for each row in our indicators table. Then I'll come down another line and create another variable called current year GDP, which will calculate our GDP measure, and I will tell the calculate function to only return the indicator year that equals our current year variable. Like so. You can see the current year variable showing up in our menu, and we can click Tab to select that. So notice a few things here. First, all I need to do to start a new variable in the measure is come down a line and then use the var or VAR keyword again. Second, variables can reference other variables. So when I created my current year GDP variable, I referenced the current year variable that I had already created. So this makes it possible for us to build compound and complex calculations in one place. Now let's continue by coming down another line to create a third variable named prev-year GDP, which means previous year GDP. And we will calculate once again our GDP measure, but this time I will tell the filter argument of our calculate function to filter on the indicator year, where it is equal to the current year variable minus 1. This allows us to say from whatever year we are currently analyzing in Power BI, look back 1 year to the previous year and return that GDP value. Next, we need to calculate the difference between our current year GDP and previous year GDP variables. So we'll come down another line, we'll add a fourth variable named diff, and we will simply type in current year GDP minus previous year GDP. And to wrap it up, we'll come down yet another line, and we will add a fifth variable named growth rate, which is equal to our divide function, and we're going to divide the diff variable by the previous year GDP variable, and we will add an alternate result of 0 just in case, and close parenthesis. There's one more step to this. When working with variables in DAX, we need to tell our DAX formula what value to return or display in our result. So the keyword that we use to do this is return. All of our variables need to be defined before the return keyword in our DAX formula. Then the final result that we want to display is added after the return keyword. So to finish, I will come down a line, write return, and then come down another line after the return and enter the variable name growth rate. In effect, what I've told DAX to do here is simply return the output of that growth rate variable, which is itself calculated from all of the variables that came before it. We've created a sort of chain of calculations here using variables, and you'll see this practice done a lot by Power BI developers when they want to break down complex expressions into individual components to make them easier to understand. One of the nice things that we can do here is we can use that return keyword as a way to examine the output of each of our variables. So let's create a table just for demonstration purposes, and I'm going to plot country and year and GDP annual growth rate. Make sure that it is not summing the year because that makes 0 sense. And let's come down and look at a country like Albania. Now let's select our GDP annual growth rate measure from our measures table, and let's add a new line after the return keyword, and let's add 2 forward slashes in front of our growth rate variable right here. Those 2 slashes are going to convert this line of DAX at line 9 into a comment. You can identify comments in DAX by their green color, whereas the rest of our DAX is mostly blue and black. We'll examine comments in more depth in our next video, but for now just know that commenting a line like this converts it into text that won't be evaluated. Then we'll go back to the line above it, line 8, and we'll put the current year variable in this line instead. If we now commit the formula, watch what happens to the third column in the table that we just plotted. It's now showing us the result of the current year variable instead. And we can do these with some of the other variables we defined, such as the diff, which is going to show us the difference between the current and previous year GDPs, or by looking at the current year, like so, or by looking at the current year GDP, like so. So this particular technique is really useful when you need to troubleshoot an issue with your measure. By looking at each variable, you can attempt to isolate where the issue might be originating. And that's something that using variables and using the return keyword allows you to do. But now that we've done that, I'm going to remove that variable right here, and I'm going to remove the double slashes in front of our growth rate variable below the return keyword to get everything back to normal. And then I'm going to take our GDP annual growth rate measure and I'm going to convert it to a percentage with 2 decimal places. So using variables in DAX carries a number of benefits. For complex measures like this one, it breaks down the calculation into its individual components, making it easier to read and easier to understand what is happening. As I mentioned a moment ago, it also makes it easier to troubleshoot and debug your DAX formulas. Beyond those benefits, using variables in DAX can also improve the performance of your measures. For example, we could have taken this selected value argument right here from our first variable and simply put that into the expression inside of our current year GDP and previous year GDP measures, like so. However, in this particular situation, we would be evaluating that expression multiple times per each row in our table visual. By putting the selected value function into its own variable like we originally had it, we evaluated it only once per each row in our table visual, which effectively cuts the query time in half. Now, the data model that we're working with here, you have to remember, is so small that these kinds of performance improvements are negligible. But in a big enough data model, one with tens of millions or hundreds of millions of rows, using variables can optimize your DAX in such a way that it can make a big difference in how long it takes your visuals to query the dataset. Now that we've covered how to use variables to optimize our DAX formulas, let's talk about how we can add comments to our formulas. For those of you who might not be experienced programmers, adding comments to code is a common practice that is used for several purposes. Foremost among these purposes is the fact that adding comments allows us to explain what the code is doing in plain language. However, it can also be used to document the history of the code, as well as a way to aid in troubleshooting, as we saw in our last video. There are two kinds of comments in DAX, and in most programming languages, in fact. There are inline comments and block comments. Comments are created inside formulas and programs by adding certain characters or markers that the system recognizes as either beginning a comment or ending it. And inline comments and block comments each use a different set of characters to distinguish them. An inline comment only affects the text that you enter after the comment marker until the end of the line that you're on, hence the term inline comment. In DAX, as we have seen, inline comments can be created by using two forward slashes, like so, or by using two hyphen or dash marks, like so. When a line has been commented, the text color is changed to green. Everything on that line of the formula after that double slash or double dash is turned into a comment, and then, once you move to the next line of the formula, the comment is ended. Block comments, on the other hand, can span multiple lines of your formula. In DAX, we start a block comment by adding a single forward slash followed by an asterisk, like so. Then we can terminate the block comment by adding a asterisk followed by a forward slash. Between those two markers, anything you enter in the formula bar will be included in the comment block. The asterisk followed by the forward slash on line 3 terminates the comment block and returns us to being able to evaluate our DAX expression. First, let's talk about using comments to explain what the code is doing. Our GDP annual growth formula here uses 5 variables to break a complex calculation down into its components. It seems simple enough, but suppose that you build a report and publish it, and then 2 years later, your users come back to you and they ask you to make some changes. You haven't looked at this report in 2 years, and you've built a lot of different reports in that time, so can you necessarily remember everything this formula does? I mean, if you're good enough at interpreting DAX, maybe you can, but you probably shouldn't take that for granted. This is where adding explanatory comments to your code can be a benefit to you, or to any other Power BI developers who need to review your DAX expressions. To demonstrate, we're going to add an inline comment before each of our variables that explains what they do. Remember that you can use either Control-Enter or Shift-Enter to add new lines to the formula bar. Then, use the double slash or double dash to create an inline comment on these new lines and explain what each variable does. Our first variable gets the current year of analysis. The second variable gets the GDP value of the current year. The third variable gets the GDP value of the previous year. The fourth variable gets the difference between the current year and previous year GDP variables. And our fifth and final variable brings all of that work together and calculates the annual growth rate. When we commit these changes in the formula bar, these inline comments become part of our formula. They now exist as text in our Power BI data model, as part of the metadata that exists behind the scenes of our report. Now, if someone else comes along to look at our report, they can read these concise explanations of what each variable is doing and maybe get a better idea of what our formula is attempting to calculate. Next, let's add a block comment at the top of our formula. This comment will explain the purpose of our annual GDP growth measure and also provide a place for tracking changes to the formula. I've added a couple empty lines at the very top, and then we'll start the block comment with a /* and then I'll come down a couple lines and do a */ to terminate it. Between those two marks, we'll start typing. Description calculates the annual GDP growth of a given country by comparing the current year's GDP value to the previous year's GDP value, finding the difference, and using that to calculate percentage growth from one year to the next. Then let's also add a section for change tracking. We'll come down a couple lines, say change tracking, and then what we'll do is we will say June 26, 2023, version 1. And we'll say, just hypothetically, on June 27, 2023, Pete added comments. So this illustrates how a developer can come in and add comments to the code that describe some of the changes that they've made. So if you've got multiple developers working on the same report, adding comments like this can provide a history of what people are doing. Then if another developer comes along in a few months after I've done all this work and needs to make changes to the formula, they can describe their changes in this change tracking section, like so. So fast forward to December 11th, 2023, and Beth comes along and she fixed Pete's boneheaded mistakes. And there were probably a lot of them, let's be honest. Ha! So you can see how all of the text between the /* and the / is automatically commented. This makes block comments really useful for adding large sections of text to our DAX formulas that can explain what they do. And of course, as we already covered, we can use comments as a means of troubleshooting our formulas. We manually typed in a / to do that in our last video, but there are also a pair of keyboard shortcuts that can make this faster. For example, to quickly comment a line like line 28 here in our formula, you can hit Control-KC and Power BI will add the / at the start of the line. Then, to remove the comment, you can hit Control-KU and Power BI will reverse it and the / is removed. We will use variables and comments in our exercises with DAX throughout weeks 2 and 3, so go ahead and practice these techniques now and get in the habit of using them. Adding comments is another one of those Power BI best practices that I think all developers should know by heart. Now that we've defined several measures in DAX from our Global Economic Indicators dataset, let's plot some of these in our report canvas. That will set the stage for us to explore the data in later videos. Let's start with a simple table visual, and then on that table visual we will add from the countries table the name column, and then from our measures table we'll add our 2020 measures, starting with population, then GDP, population density, and finally GDP per capita. Now let's move our table and resize it so it takes up the bottom quarter of our report page, perhaps. And then I'm going to add a little drop shadow onto it because, that's what I tend to do to create that visual distinctiveness that we talked about in our week 1 videos. Now, let's try to map our countries on the globe. This will allow us to explore some of the visualizations that Power BI offers for plotting geospatial data. Before we do that, I'm also going to sort my table by population density in descending order, just so we can get a look at some of the data that's in there. Now, as of the time I'm recording this video, there is a standard map visual in Power BI Desktop that is called just Map. It's visible right here under the Visuals menu, and so we'll add this to the upper portion of our screen, like so. Let's drag and drop onto our map visual from the data panel the ID column from our countries table. And I just realized why there are no circles appearing on the charts, because Power BI added the ID column to the legend area of our visual right here. So I'm going to drag this over to location now. And when I do that, hey, we get a bunch of circles all over our globe that show us where our countries are. So this map visual is very basic. We can click and drag our mouse to pan around, and if we use the scroll wheel on our mouse, we can zoom in like so. I'm going to do a little bit of resizing here. I'm going to shrink my table visual a little bit, and then I'm going to increase the size of the map visual so it's a little bit better. There we go. And I'm also going to bring it over horizontally so it's not wrapping around like it was doing a second ago. That looked a little weird. If we select our map and go to the format settings, we can see that there are a lot of ways that we can actually customize this map. If we go to map settings and go to the style, you can see that there are 5 different preset styles that we can choose between. Arial, which looks like this. Dark, which I kind of like because I'm all about dark mode when I'm working with software. Then there's the light style, grayscale, and finally road. If we zoom in close enough on the road style, we should see highways and roads becoming visible just like that. Pretty cool, huh? Back to the format settings, you can turn map labels on or off by hitting this little toggle button here, which will remove the names of continents, states, rivers, oceans, etc. And you can also control whether the map will automatically zoom in or out based on your data using the auto zoom feature, which is under the controls menu. You can also add category labels to your report by toggling on the option here, which will display the 3-digit country code of most of the countries on our map. Now, in terms of data options, you can drop location names into the location area. For instance, if I switch ID to the name of our countries, we will get a lot of stuff on here. However, notice that the state of Georgia is highlighted here, which, our data set's not talking about the US state of Georgia. It's talking about the country of Georgia in the Caucasus region. So this is way off. So if we go back to ID, though, we can still see some of the same problems. I'm going to put ID back in here, but notice that when we zoom in, our map seems to think that Australia is located in the middle of the United States, which obviously it is not. Furthermore, if we zoom out and go over to Europe, we see that it also seems to think that El Salvador, SLV, is in the middle of Germany. So obviously that's not right either. There are definitely some issues with the basic map visual and where it thinks countries are located based on their 3-digit country codes. However, we can get a better map here if we remove the ID from the location area, and let's use latitude and longitude instead. So go to the latitude area, and then go to countries, and put in latitude, longitude, go to countries, and put in longitude. First thing we'll notice is that our category labels are now showing each country's coordinate, so what we can do to get rid of that is go to our format settings and turn off the category labels. And now if we zoom in on El Salvador, we can see that it's located right where it should be, and if we zoom back out and zoom in on Australia, we also see that it's located right where it should be. But the other thing that we will notice here is that these location coordinates, these latitude and longitude coordinates, are not actually centered on each country's geographic center like we thought they might be. They're actually centered on each country's capital city, is what it looks like. So for instance, the US bubble is centered on Washington, D.C., and Canada's bubble is located over Ottawa. So using latitude and longitude from this data set has its own set of issues. So what happens then if we remove latitude and longitude from this map and we use the ISO 2 code column instead from our countries table? Well, this actually looks a lot better. Australia and El Salvador are right where they should be, and all of the bubbles on our map appear to be aligned on each country's geographic center. So that looks okay. Apparently, the basic map visual does better with the 2-digit ISO country codes than it does with the 3-digit ISO country codes, so you might want to make note of that. However, one thing to know about the basic map visual is that as of now in June 2023, it's due to be replaced by the newer Azure Maps visual. So by the time you take this course, the basic map may no longer be available. Now, I'm not going to show you the Azure Maps visual right now because as of now in June 2023, it's terrible. It's really not a good visual. I don't want to work with it. Hopefully it's better by the time you get a chance to work with it, but I'm just not going to go through that. So what I will show you next is actually going to be the shape map visual that we used in week 1. Go to our visuals menu, and I'm going to change it to the shape map. Now, when we switched to the shape map visual, it defaulted me to the same US states map that we used in week 1. And you're probably thinking, whoa, Pete, that is not the world, So if we go to the Map Settings menu on our Formatting panel, and we go to the map type, there's a drop-down menu, and the last option on the drop-down menu is Custom Map. So if we select Custom Map, and then add a map type using this Browse button here, look in your Week 2 exercise files, and find the file named worldcountriesgeomap.json. This is another JSON file like the one we talked about a few videos ago. Now, this specific kind of JSON file is known as a GeoJSON file, and it contains a series of coordinates that map the boundaries of world countries. So if we upload this file to our shape map visual in Power BI like so, it will draw those countries on our shape map, just like you can see here. So if you search the internet, you can find many different examples of GeoJSON files that you can upload to Power BI Desktop and play around with. Now let's add some data to our shape map. We're going to put the ISO 2 code into the location area. And then if we make this a little bit bigger, I'm going to jump into focus mode to make this a little bit bigger. I'm going to point out a few interesting things here. You've undoubtedly noticed a few gray areas on the map, and you might be wondering what's going on in these territories. The first of these in Latin America, which I'm circling here, is French Guiana, which is a territory of France and is considered to be fully under the control of the French government. If we move over to Africa, we can also see a disputed territory in Western Sahara, as well as the Republic of Somaliland, which is a breakaway state that as of 2023 remains unrecognized by most, if not all, countries in the world. And going back to our video where we mentioned Taiwan, you can also see that Taiwan is shaded in gray because that territory is also technically still in dispute. So I'll say this, it's up to you which map visual you want to use for this course. I'm using the shape map visual with the custom GeoJSON file, but you can also use the original maps visual, or you can try to use the Azure Maps visual if you want to. To fill this out, I'm going to now add our region column to the legend area. And then to get these colors to show up, I'm also going to add another column. I'm just going to add ID probably to the color saturation area. And that's going to shade all of our countries by their regions that they belong to, according to the World Bank. The other thing I'm going to do here, since we have so much empty space on the left and right side of the visual, is I'm going to go to my legend settings, and I'm going to move the legend over to the center right position, which, looks a little bit better, I think. So now our regions are color-coded, similar to the census regions and census divisions that we used in last week's lessons. All right, I think that's enough mapping for now, so pick the map that you like best from the available options, and let's meet up in our next video where we will build out our table visual with some great new features that you might not be aware of. Table visuals in Power BI can probably seem really uninteresting at first. After all, don't they just display some flat tables of data? Doesn't seem like they offer a lot of visual flair, do they? So why use a boring table when you could just use some fancy, colorful chart or map? Well, I'm here to tell you that you need to give tables a little more credit because they have some great features underneath the surface that you probably don't know about. In this video, we're going to learn about these features and show how you can use them to make your tables look amazing. Before we get started, I'm going to make some quick formatting changes to our table. I'm going to get rid of the horizontal grid lines, like so. Then I'm going to increase the row padding a couple of points. I'm going to get rid of our totals row, and I'm going to get rid of the alternate background color on our row shading. Now, let's start with conditional formatting because we've already briefly mentioned it a few times in this course. If you'll remember from week 1, we used conditional formatting in our U.S. states report. First, we used it to create color rules for our states table that allowed us to visually associate each row of our table with the census region it belongs to. Then, by defining a measure in DAX and then clicking the FX button that we find in several different places throughout the formatting panel, we were able to use a form of conditional formatting to create dynamic, data-driven chart titles. Well, we can also use conditional formatting to add some simple data visualizations inside of our table, as well as inside of matrix visuals. So let's explore how to do that. First, select our table if you haven't done so already, then go to the Visual Editor, and right-click on our population density column. One of the options we see on this menu is conditional formatting, and if we hover over that option, we see 5 options to choose from: background color, font color, data bars, icons, and web URL. For population density, let's select background color and see what that does for us. We'll get a pop-up window where we can configure the conditional formatting, and what you'll notice primarily here is this big color gradient in the middle of the pop-up. This allows us to select which colors we want to use when looking at the lowest values in our column versus the highest values in our column, with lowest being on the left and highest being on the right. We can also enable this option to add a middle color if we want to set a third color in the middle of our gradient. So if we change our lowest value color from this light blue to white and keep blue as our highest value color, then click OK, Power BI is going to shade in the background of all the cells in our population density column according to where the numbers fall along that color gradient, with 0 being the lowest value and our highest value being whichever country has the greatest population density, which is Macau off the coast of China, as you can see. And as we scroll down the table, the gradient gradually disappears until we reach the bottom where all the cells are shaded white. And in truth, Macau and Monaco and Singapore and Hong Kong are so densely populated relative to all the other countries in the world that this gradient is really dense blue at the top of our table and then very quickly disappears into that lighter blue and then white, not even that far down the table, to be honest. But this allows you to see that associating the intensity of a color with the value of the underlying data is a pretty good way to create a visual relationship between the data visualization and the underlying data. Now let's compare this kind of conditional formatting with the font color conditional formatting. Let's go back to our column, right-click, and go to Remove Conditional Formatting and select Remove All. Then let's right-click again, go to Conditional Formatting, and this time we'll select Font Color. Now, we can't do a white to blue gradient here because all of our cell background colors are white, so white text will just vanish against that white background. I think font color gradients work really best when you transition from red to blue or red to green, so let's change our lowest value color to red, like so. And then we will keep our highest value color as blue. Now let's watch how Power BI handles this. If we scroll through, we can see how the color changes quickly from blue to purple somewhere in the middle, and then we get to red as we get to our lower population density countries. Now, I'll admit I don't think this looks nearly as interesting as the background color gradient we used a moment ago, because it's kind of hard to see the contrast in colors from row to row. We kind of move from blue and then suddenly to purple and then red. It's all kind of very abrupt. So let's actually get rid of this font color formatting by right-clicking and using Remove Conditional Formatting. And now let's try a different kind of conditional formatting, which is probably my favorite, data bars. Data bars are used to add a horizontal bar to each cell, similar to a bar chart like the ones that we've used in this course so far. So if we click on population density and select data bars, notice how the pop-up window here allows us to set the color for a positive bar, like this, and a negative data bar, like this. This can be really great for whenever you're working with data that can be both positive or negative, such as financial data. Now, our population density can only be positive values, so we'll just ignore the negative bar setting here and keep the positive bar as blue. Then let's click OK and take a look at the result. And I actually think that this looks really great. The data bar is a phenomenal way to add a great visual cue to your table that can more easily demonstrate to your users the difference between values. For instance, if we were to add the data bar to our 2020 GDP per capita column like this, and sort that column in descending order, the data bars are doing a really good job of showing the massive jump in GDP per capita from Luxembourg to Monaco. I mean, no other country in the world even comes close to Monaco's economic output per person, and these data bars do a really good job of illustrating that. So we can show these conditional formatting types side by side. I'm going to add the background color formatting back to our population density chart. So I'm just going to go here, right-click, Remove Conditional Formatting All, and then on Population Density, right-click again, Conditional Formatting, and I'm going to add the background color back in with white as our lowest value, and then click OK. We won't take a look at the web URL conditional formatting in this video, but let's take a moment to look at our choices for the icon conditional formatting. I'm going to go to 2020 Population Density again, then Conditional Formatting, and select Icons. When icons are added, we can set rules that tell the table, basically when rule 1 is met, display this icon. Otherwise, when rule 2 is met, use this icon. And otherwise, when rule 3 is met, display this other icon, and so on and so on. If we open up this style menu on our pop-up, you can see the icon styles that we have to choose from, and there's a pretty good variety that we have here. For example, if we want to show an icon that represents a percent completion metric from 0% to 100%, one of these icon sets that I'm circling here might actually be really useful for that. Or if we want to visually indicate increases or decreases in a certain metric, like our GDP annual growth, we can use one of these icon sets that show arrows pointing up or down. Or perhaps we have some threshold value that constitutes a warning to our users, and we want to add one of these flag icons down here to symbolize that and draw attention to it. For example, if I was making a report that looked at some of the servers that I maintain for my job here at Davidson, I might want a yellow flag that tells me when one of the servers has less than 10% disk space remaining. Or we might have a report that shows project management milestones, and you might want to show a red flag that indicates whenever the due date for a specific task is less than 10 days away. There are many potential uses of icons in Power BI, and we'll look at some of those uses in an upcoming video. Next, let's exit this and talk about Sparklines. If you've used a lot of Microsoft Excel, you might be familiar with Sparklines already, but they're a relatively recent addition to Power BI, and they help us create a simple trend line visual inside of our table that can add a lot of rich detail to our report. To add a sparkline, simply right-click on one of our measures in the visual editor and find the option to add a sparkline. This will cause a new pop-up window to appear where we are prompted to choose which measure or column we want the sparkline to use for displaying data on its y-axis, and which column we want to use for the x-axis. Before I go further, our goal with this sparkline will be to create a small line chart that shows the yearly trend in each country's gross domestic product. So, for our y-axis, we will want to select the GDP measure from our measures table. And for our x-axis, we will want to select the year column from our indicators table. Then, click the Create button and watch how this adds a really nice little line chart to each row of our table. This is a sparkline. It gives us a concise way of visualizing trends in our data within the scope of a table row. And there are some great ways that we can supplement this. First of all, if tooltips are enabled on your table and you hover over each sparkline, you can enable a little tooltip that displays percent changes. Let's actually go ahead and do that. I'll go to Properties, turn on Tooltips, and then I'll hover over Luxembourg, and we get a little pop-up that says the GDP by year trended up, resulting in a 382% increase. So the tooltip gives us this really brief narrative that describes the yearly trend of the data from the first year to the final year that is visually represented inside of the tooltip. We can also configure tooltips through the formatting panel in Power BI Desktop. For example, if we scroll down to the section that says Sparklines, we can add markers to the sparkline that help highlight certain points along the line, such as the highest point, or the lowest point, or any negative points. Now, this may not help much with our GDP figures since these usually trend upward. We can probably tell for most of these that the lowest point is going to be on the left side of the GDP trend, and the highest point is going to be on the right side of the GDP trend. And we shouldn't have any negative numbers because GDP should never be negative. However, what if we wanted to see our GDP annual growth measure visualized this way? Let's go over to our visual editor and add another sparkline. And this time we will put our GDP annual growth percentage on the y-axis. And once again, we will put year on the x-axis. And then click Create. Now that we've created our sparkline, let's go back to the formatting panel. Let's change the sparkline from GDP by year to GDP annual growth percentage by year. And then let's turn on negative markers and let's color these in red. The result is that our second sparkline now gives us these red markers that help us pinpoint years when a country had negative GDP growth. We can also use sparklines to create column visuals by changing the sparkline type under this menu from line to column. And this looks really cool, and it still allows us to see years with negative GDP growth as they protrude from the bottom of our x-axis. The only thing I wish that we could change here is that I wish Power BI gave us an option to shade those negative bars in red. That would probably look better. But hopefully by the time you take this course, sometime in the future, Microsoft will decide to give us that option. Anyways, that's our video about conditional formatting and sparklines. We'll probably revisit these features later in the course, but for now, let's keep building the rest of our report. In week 1, we used tooltip pages to give ourselves a glimpse of yearly detailed data from our overview of U.S. states. By hovering over a state in either our table or map visual, we were able to display a small line chart which showed us the yearly change in population for each state. This is a really useful technique when you have a small amount of detailed data that you want to display. But what if you have a lot more data that you want to show about that specific state, or country in this week's case? With our global economic data, we have measures for GDP, population, population density, and growth rate, and those probably won't all fit on a single tooltip page. So what should we do if we think we need a full-sized page that we can dedicate to one country at a time? In Power BI, there is a mechanism that we can use to navigate from an overview page about all of our countries, like the one that we're looking at now, to a detail page about a single country, and we can do it interactively. This mechanism is known as drill-through, or drilling through, and it allows you to create secondary pages in your report that act as drill-through destinations or targets, so to speak. These pages are known as, you guessed it, drill-through pages, and they work by interactively applying context filters based on the data that you select in the first page. So in this video, I'll show you how this works as we add a drill-through page that allows us to focus on one country at a time. We'll start with the obvious first step, creating a new page. Come down to the bottom of our report canvas, and let's rename our page 1 as Overview, and then click the green plus button to create an empty page, and let's rename this as Country Detail. And then let's do some quick formatting to add a subtle background color, like a light gray. Flip the transparency to 0%. And now, while we're here on the formatting panel, we will see that there is, under the page information section, a page type drop-down menu. Recall that this is the same menu that we used to create a tooltip page in week 1, and there's a third option in here besides the standard page that we already have and a tooltip page, and it's the drill through option. Selecting this option from the menu causes some new options to appear down below, most notable of which is this section where we can add data. Using this button, we're going to add some columns from our data model here, and these columns are going to tell Power BI what values it should be filtering on when it navigates us from our overview page to our country detail page. So let's click the button and go to our countries table, and let's add ID and ISO 2 code and our country name to this section. While we're here, let's also turn off this option to keep all filters. I'll link an article below this video that explains what this option does, but suffice it to say for now that this option doesn't really help us for this particular video. Notice something that happened when I added those columns to the drill-through settings. A small icon appeared in the upper left corner of the report canvas. It looks like a back button, and that's because it is. Power BI automatically created this button for us because it will allow us to navigate back to the overview page after we've performed a drill-through action. We'll cover button actions in more depth later in this course, but this is a good little preview of what these things can do in Power BI. Before we go back to the overview, I'm actually going to resize this, just make it a little bit bigger so it's easier to see. Now let's add some visuals to our country detail page so we can have something to look at when we drill through. We'll start with a simple table visual from our menu. So I'll add this, and we're going to display our economic indicators on a yearly basis. So we will add our year column from the indicators table, and make sure that we are not summarizing first of all, and then we're going to sort in descending order. This way our most recent years are showing up at the top of our table. Then we'll go to our measures table, and we're going to add our GDP measure, our GDP annual growth rate. Then we'll follow up with population and GDP per capita. Then let's resize our table visual. And then let's go in and add some style elements, like we're going to add our drop shadow as per usual. And then let's make it look a little more interesting by adding some conditional formatting like we did in our last video. I'm going to go to our object editor, and I'm going to right click on the GDP annual growth rate, and I'm going to select conditional formatting and icons. We're going to create a simple set of rules that say when GDP growth rate is negative, display a red down arrow. When GDP growth rate is 0, display a yellow dash, and when it's positive, display a green up arrow. We simply need to select our style set, which is this one right here, and then we're going to configure the rules. For the first rule, I'm going to change this percent drop down to number. I'm going to change this to number as well, then this one, and finally this one. And then I also have these drop-down menus that let me select which operator I want to use. On some of these I can choose between greater than or equal to, equal, or is blank, and some of these I can choose between less than and less than or equal to. What I'm going to do is I'm going to say greater than or equal to negative 9,999 and less than or equal to 0 is equal to a red down arrow. Then if the value is equal to just a flat 0, we'll do the yellow dash. Finally, if our number is greater than 0 and less than or equal to 9,999, we will have the green up arrow. Then click OK, and we should get these little icons that show up inside of our GDP annual growth percentage column. This is one of the other conditional formatting types that I did not showcase in our last video, but I think it works really well for giving a nice graphical indicator of our GDP growth rates. Now that we've built our table, let's add a chart to the report that visualizes a couple of these measures for us. In particular, I'd like to see a combination line and column chart that shows us our yearly GDP figures. Years will go along the x-axis, and the numeric data will go on the y-axis. So we'll go to our visuals menu and we'll find the option for line and stacked column chart, which is right here. Once we've added it to the report canvas, let's resize it, and then let's go ahead and using the object editor, we will add year to the x-axis from our indicators table. Then we'll drop GDP into the section that says line y-axis, like so, and we'll drop GDP annual growth into the section that says column y-axis, like so. And don't forget to add that drop shadow. Now, I don't want to examine this data just yet because right now we're still looking at all of the countries in the world. And you can probably tell that by the absolutely obscene population and GDP numbers that we're looking at. Currently, these visuals are summing those numbers for every single country in the world, not one country at a time. We'll get to that. First, let's do some formatting on our new chart. We're going to go to the settings for our lines. So if we select the chart and go to our format settings, we'll find a section that says lines, which we can expand. And here we can change the color and different format settings for the line part of our chart. We're already using a nice dark color here that adds a lot of visual contrast between the line and the columns. So I'm going to leave the color alone, but I am going to add some markers to these lines. If I come down a section, I can enable markers and open this up, and I have the ability to add circles or squares or triangles, and each point on our chart, on this line chart, gets represented with that point. I think these circles are a little too big, so I'm going to maybe ratchet these down a couple points, and I'm also going to make our line a little bit smaller by making the stroke width property 1 pixel instead of 3. I'm going to make one other small tweak here, and that is I'm going to fix the minimum and maximum values on our x-axis so the chart will fill out its space a little more. We already know that we don't have any data before 1973 or after 2021, so if we come to the x-axis section, we can just insert those values right here into these minimum and maximum boxes. That lets our chart fill out the space a little bit better and makes our data a little bit easier to see. And now we have less empty white space in our chart. Next, let's do a little more conditional formatting. When we look at our GDP annual growth rate, I would like to shade the columns red when the value is negative, but keep them blue when the value is positive. So let's go to the column section of our formatting panel and then click the FX button next to this blue color picker. This will open our conditional formatting settings for the column color. Then let's change the format style from gradient to rules, and then change the field from sum of year, which doesn't make any sense, to go to our measures and find GDP annual growth percentage. Then in this rules section, we'll just say if the value is greater than or equal to negative 9,999 as a number, but is less than 0, then shade it as red. We're not explicitly going to state a rule here to set the color when it is a positive value because we don't need to. Power BI is actually smart enough to apply the default color of blue when it does not find a rule that applies to the specific condition. So we're going to click OK, and now we can see that we've added red bars where the GDP annual growth rate is negative. Okay, I think that's enough formatting, so let's actually go back to our overview page now, and let's demonstrate the drill through page in action. Simply go to either our table visual or our map visual and right-click on a country. I'm going to select Sweden from our list, so I'll right-click on Sweden, and we see in the menu that pops up there is a drill through option, and when we hover over that, a side menu appears that shows the name of our country detail page. Another way we can do this is to simply hover over Sweden, and if we wait long enough, a little drill through option appears here that we can also use. Simply click this, and Power BI will take us to our drill through page. What we see is our country detail page, but now everything is filtered on Sweden. And we can confirm this by either looking at our filters panel on the right side of our report canvas, or by hovering over one of the visuals on our report canvas. If we hover over one, we'll find an icon that looks like a filter in the upper right corner. And when we hover over this, we will get a small pop-up that displays all the filters that are affecting this visual. And it tells us that there is a filter in place that returns only data where the country name is Sweden. We're going to talk about the filters panel in depth in an upcoming video, but you can see what filters are being applied on your drill through page here by looking at the section that says filters on this page. And find the filter card that is shaded in gray, which means this filter has been applied. But instead of looking at the filters, let's add a new visual element that more quickly and prominently reminds us which country we're looking at. To do this, let's add a new measure to our model, and we're going to call this measure selected country. And the formula is just going to be equal to selected value of our country's name column. Then use close parenthesis and hit the commit button. And now we're going to go back to our insert tab, and we're going to add a card visual to the report, which is a small visual right here with a little 1, 2, 3 symbol on it. We'll add this, we'll move it up to the very top of the report, and we'll resize it so that it fills up the whole width of the page from left to right. Next, let's go to the object editor, add data, measures, and look for the selected country measure, which I accidentally put on our countries table, and I will fix that in a moment. Click selected country, and we can see our card visual. Now there are two bits of text that we can see here. The first one, that big giant thing that says Sweden, is our callout value, and the second one below that's getting cut off is known as the category label. I'm going to turn off the category label by going to our formatting panel and toggling that option off. So now we just see the name of our country, Sweden. While I'm here, I'm also going to go ahead, you know what I do, add that drop shadow on there. And then I might resize this a little bit just to make sure that it is perfectly centered on the page using my little alignment tip right there. And now the name of our country is centered on the page at the very top. So what we've in effect done here is created a page header that displays whatever country we're currently looking at. Now let's examine the data itself. We can see that the table shows our yearly figures sorted by year in descending order, and our conditional formatting icons give us a nice visual cue that highlights the years where GDP growth for Sweden were positive or negative. Where we have red down arrows, that means their economic output for that year had decreased relative to the economic output from the previous year. And when we look at our line and column chart, we see the same story beautifully illustrated by the conditional formatting we added there. The chart also does a good job of juxtaposing the overall GDP numbers against the GDP growth rate, because we can follow the path of our line chart as it goes up over time. And we can see that the years where GDP decreased from the year before line up really well with where our red down bars are occurring. And as you can see from the year 2009, the bigger the dip in the line chart, the taller our red bar appears to be. And we're actually starting to see a history of some major economic events that are occurring. In 2020, we see the contraction of the global economy due to the initial shock of the COVID-19 pandemic. In 2008 and 2009, we can also see the Great Recession, where a lot of established Western economies fell into a brief but severe economic decline caused by systemic failures in our banking systems, particularly centered on home mortgages. I actually got to experience that crisis firsthand because at the time it happened that I was working a job doing legal due diligence for investment banks that were packaging up these mortgage-backed securities. And yeah, that job was about as exciting as it sounds. And let's just say that I'm really glad that I ended up in a career as a software developer. Now that we've reviewed our data for Sweden, let's use the back button in the upper left corner to return to our overview page. Now, when you're working in Power BI Desktop, you need to use the Control left click to engage the button action. If you don't use Control at the same time as you click, the editor will just select the button, like you can see on the formatting panel right there, because it's assuming that you just want to make changes to the button. But if you do Control left click, that will trigger the button action, like it just did, and that takes us back to the overview page. Now, if you publish this report to the Power BI Cloud, your users don't need to use Control Click. This is only something that you need to do inside of Power BI Desktop. Now let's find another country to look at. I'm going to sort my table by country name in ascending order, and then I'm going to scroll down until I find Nigeria, and then I'm going to drill through on Nigeria to our country detail page. When we look at Nigeria, we see an interesting perspective on the economic stories that we talked about when we were looking at Sweden. Of course, the initial shock of the COVID-19 pandemic was felt almost universally, and we can see that Nigeria's GDP took a pretty big hit in 2020 as a result. But notice that when we look back to the period of the Great Recession in 2008 and 2009, Nigeria's economy was not affected by those events at all. Their economy continued growing at a respectable rate of around 8% annually. This illustrates that the Great Recession primarily impacted either Western countries or countries with deep ties to Western financial institutions. With Nigeria's economy not being tied strongly to banks in the United States and Europe, at least not at the time, they probably barely even noticed that anything happened in 2008 and 2009. Now, let's contrast Nigeria with a different country, like Singapore. I'm going to go back to the overview page, and then instead of sorting by name, I'm going to sort by population density in descending order, so I can quickly find Singapore because I know it is one of the most densely populated countries in the world, and then I will go to drill through on country detail. Now, Singapore, like Nigeria, is also not a Western country, obviously, but it is a highly developed industrial economy with deep ties to banks in both the United States and Europe, as well as a manufacturing sector that exports a lot of goods to Western countries. Singapore's economy, as we can see from the chart here, kept growing in 2008 and 2009 despite the Great Recession, but at a much slower rate compared to previous years. So Singapore is a really interesting example of a country that may have been more indirectly impacted by the Great Recession, as the decrease in spending in countries like the United States resulted in a sharp drop in American demand for overseas goods and services, which in turn led to a decreased manufacturing output in Singapore and a significant decrease in their gross domestic product. At least that's one possible contributing factor. One last thing, which is a small note of caution about combination line and column charts. As you can see, these kinds of charts allow us to view two different data series on top of each other, which can be really useful and interesting, as I have hopefully demonstrated over the past several minutes. However, these charts should probably come with a warning label because of the fact that they can contain two separate y-axes. When we look at our chart, you can see here where we have percentage figures on the left edge of the chart associated with our columns showing GDP annual growth rate. But we also have dollar figures on the right edge of the chart associated with our line chart, which shows GDP by year. Pay attention to things like these because they can be confusing. If you're not paying close attention, your brain might accidentally associate the labels on the left side of the chart with the line, and you might interpret the data incorrectly. Still, in spite of that warning, I think this is a great chart that can tell us some really interesting economic stories. So take some time to explore different countries in this data set using these drill-through operations. I think you'll find some interesting events hidden in the data. And we're definitely going to throw some comprehension questions at you that will quiz you on your ability to find these stories and interpret the data that you're seeing. In our last video, we briefly talked about the filters panel on the right-hand side of our report canvas, which you can see here, and how we can use this panel to see what filters are affecting the visuals in our report. Let's take a few minutes to discuss the filters panel in some more depth, showcase some different ways that you can use it, and contrast it with slicers, which is a topic that we've already covered a little bit in week 1. First of all, the filters panel is also known as the filters pane. In fact, it's pretty much universally called the filters pane, but I've chosen to say panel in this course because our closed captioning software in the first version of this course thought that I was saying P-A-I-N pane rather than P-A-N-E pane. And honestly, there's only a one-letter difference between P-A-N-E pane and panel. And they mean the exact same thing in this context, so that's why I chose to use panel instead of pane. So just know that whether I say filters panel or filters pane, this expandable and collapsible portion of Power BI Desktop right here is what I'm referring to. Now, as you've seen previously, the filters panel can be expanded or collapsed, and if you notice the eyeball button at the top of it, you probably gathered that we can make the filters panel completely invisible in our report. You may have also guessed that we can add filters to our panel by dragging and dropping them from our data panel onto these little boxes that say Add Data Fields here. There are 3 different levels of filters that are available through the filters panel. We have report level filters, page level filters, and visual level filters. I like to refer to these as filter scopes, and they can be configured separately or together to control what data is visible anywhere in your Power BI report, from the very highest level to the very lowest. Report level filters are visible under the section labeled Filters on All Pages. As you might have guessed from this, report level filters will filter the data on every page of the report and every visual on all of those pages. So if you add a field from your data panel in this section and enable filtering on it, your entire Power BI report will be affected. As an example, if I drag the region column from our countries table onto this section here and tell it to filter on the East Asia and Pacific region, this will change every page that we've created so far. And to see how this can potentially be a bad thing, let's disable East Asia and Pacific and do Europe instead, and then let's go back to our country detail page. And notice how all of the data is blank. This page was already filtered on Singapore, but we just put in a report level filter that basically overrides that and says only return data from Europe and Central Asia. Singapore not being in Europe or Central Asia, that has basically broken this page for us. So if we go back and then return to East Asia, our page is working again. So that's what report level filters can do, and you have to be a little bit careful with that. If you don't want to change all of the pages in your report, we can delete this filter from the panel by clicking the small X button in the upper right corner, which becomes visible when we hover over the filter. This will remove it, and now we can move on to the next type. Page level filters are visible under the section that is labeled Filters on this page. Any field that you add here will only affect this specific report page that we're looking at and will not carry over to any other pages. This can be really useful for situations where you're building a report that is several pages in length and you want to perhaps have different perspectives on the data on each page. For example, if we wanted to perform an in-depth analysis of each of our global regions with visuals that are customized to highlight particular stories from each region, we could probably want to build a separate page for each region in our report, and then we could use filters on each page to make sure that the data stays focused on each particular region. Finally, visual level filters only become visible on the panel when you have selected a visual from the report canvas, and they will display any and all fields that you have added to your visual, plus any additional fields that you want to use for filtering. For example, if we select our table visual here, we can see that every field that we have added from our data panel is visible in this section that says Filters on this visual. But I can add more filters to this visual by clicking and dragging from our data panel, like if I drag capital city onto here. Now, as an example, If we add region onto this and then select the region of North America from our list, we can display only the data for North America in this table, while the rest of our report page, as you've probably noticed, still shows the data for the rest of the world. Now, the important thing to note here, however, is that cross-filtering from the other visuals on the page can affect this. So we may need to use the Edit Interactions feature that we discussed in week 1 to make sure other visuals don't mess this up when we click on them. For example, if I click on Russia in this visual right here, now our table is empty because we're trying to filter that table both on North America using our filters panel, but we're also cross-filtering from our map visual. So we want to avoid situations like those, and the Edit Interactions feature can help us do that. To demonstrate some of the different features of the filter panel, I'm going to begin by adding the name and region columns to our page level filters, like so. First, I'll point out that each of these filters on the panel is expandable and collapsible, as you just saw, and each one of these is referred to as a filter card. I guess because they're all shaped like cards with rounded edges, slightly rounded edges, anyway. Second, note the language that appears at the top of each card. When nothing is selected from our card, each one says something like name is all or region is all to let us know that we're currently selecting all values. If we change one of the filters, like setting region equal to Sub-Saharan Africa, that language updates to say region is Sub-Saharan Africa. So the filter card is giving us a little plain English description of how it is affecting the report. And this is a nice little informative visual cue that you can use. Also, notice how I forgot to take the North America filter off of our table visual here. You can see if we hover over that little filter, it says region is North America and region is also Sub-Saharan Africa. There is no country in the world that is both in North America and Sub-Saharan Africa. So I'm going to go back to my table visual and I'm going to remove that region filter, and that looks a lot better. Now we're filtering our entire report page on Sub-Saharan Africa. We can see everything nicely laid out here. If we go further down the card, below the sentence where it says is Sub-Saharan Africa, we can see that there is a filter type drop-down menu which is currently set to basic filtering. Basic filtering is a simple, scrollable, and searchable list, as you can see here, which displays all of the distinct values for the column. Here we see each region from our country's table, accompanied by a checkbox, and off to the right is a count of the number of rows in our country table that correspond to each distinct value. We can click the checkboxes to select multiple regions, like so, and there's even a checkbox at the bottom that says Require Single Selection, that, when enabled, will force us to only select one region at a time, like this. Also, note that to clear a filter and return it to its default state of filtering on all values, if we hover over the filter card, there is a small eraser icon that appears in the upper right corner, and if you hover over it, it says Clear Filter. We can click this to clear the filter value and return it to the default state, like so. If we go back to our region filter and turn off the option to require single selection, you'll notice that the next option in our filter type list is Advanced Filtering. To demonstrate advanced filtering, I'm actually going to use our name filter instead, where we can see all of our country names. And I'm going to switch to advanced filtering here. When we use advanced filtering, we can implement some slightly more complex logic when we want to filter our data. When working with a text column like this one, we can open up this menu that gives us options to look for countries using certain keywords in them. And we can use these different operators, like whether those keywords are contained or not contained in the name, whether the name starts with or does not start with the keyword, and so forth. So if we select contains from this list, and then below that we type in the letters REP, and then click this little Apply Filter button below, this will filter our report page on all countries that contain the text string of REP, which effectively gives us a list of all the countries that have the word republic in their name according to the World Bank data. Like we can see the Democratic People's Republic of Korea, or North Korea as it's otherwise known, and the Democratic Republic of the Congo, the Dominican Republic, and so forth. Now let's clear the filter I just created and let's show the next type of filtering that we can demonstrate, which is called top-end filtering. Top-end filters give us a great method for reducing the amount of data in a particular visual by returning, for example, the top 10 countries ranked by GDP. Let's explore how to do that. Select your table visual, then go to the visual level filters, expand the card for country name, and change the filter type from basic to top-end. Next, let's drag the 2020 GDP measure from our data panel onto this by value section right here, and then let's select top 10 and click apply filter. In effect, what we're doing here is telling the visual to only show the top 10 countries ranked by their 2020 gross domestic product. And after we've clicked the Apply Filter button, the language at the top of the card updates, tells us it is filtering top 10 by 2020 GDP. And when we look at the table, we can confirm this. We can see the United States, China, India, South Korea, Japan, Germany, all the usual suspects. These are our world's top 10 biggest economies in the year 2020, measured by their gross domestic product. Also notice how the change in our filter criteria has affected our conditional formatting, particularly the population density and GDP per capita columns. Now if we sort on population density, we see that South Korea is the most densely populated of our top 10 countries, and Brazil is the least densely populated. And the gradient actually looks really good here because we've got a good range of population densities. We've got South Korea, which is very densely populated, versus Brazil in white, which is, barely populated at all in terms of number of people per square mile or per square kilometer. So this actually makes our conditional formatting look really cool, I think, when you've got it reduced down to a smaller population of countries. Now, another way that we can use this is to find our world's bottom 10 countries by some measure. So let's go back to the filter card. Let's get rid of the 2020 GDP value. Let's change this to bottom 10, and let's do bottom 10 by GDP per capita. And then click Apply Filter, and we get a much different set of results. But one thing I'll say before we leave the idea of top-end filters, you can only add top-end filters to visual level filters. They cannot be added to page level or report level filters, so make sure that you make note of that. Other than small limitations like that, you can do a lot of cool things with the filter panel, especially in situations where you want to present a small subset of data on your page. And if you find yourself in a situation like that and you want to keep your users from making changes to these filters, either at the report level or the page level or the visual level, there are some additional features that we can use to effectively lock filters in place so they can't be changed. The first of these options is literally locking the filters. If we look at our filter cards, we can see small padlock icons in the upper right corner of each one. And if we click the padlock icon, the padlock will lock into place, which symbolizes that users can no longer change these filters. When your report is published, your users will still be able to see the filter card on the panel, and they'll be able to see it when they hover over a visual and look for the filters affecting this visual feature right here. But otherwise, they won't be able to change the filter in any way. And this is good for situations where you want your users to know how the data is being filtered, but you don't want them to be able to modify that filter. Now, the other possibility is to hide a filter entirely. And to do this, you can simply click the eyeball icon that exists on each filter card. When a card is hidden, a slash will be visible through the eyeball, and this means that your report users won't even be able to see that the filter exists, let alone be able to change it. So to illustrate this, here's a shot of the filter panel from a finance report that I developed here at Davidson College, from the perspective of an end user. The two gray cards are the filters that are enabled on the report. So notice how the first filter, account description, has the padlock icon on it, and it says account description does not start with 1 and does not start with 2. So our users can see the filter and they can see how the data in the report is being filtered, but they can't change it. They can't do anything about it. So this is to make sure that they don't accidentally change finance accounts, which could inadvertently give them bad results in the report. Meanwhile, the second filter, fund status, is set to active, but the users can change this filter if they want to see inactive funds, which you can tell by the fact that there's no padlock icon on it. So the other 4 filters are not enabled, but they can be modified by the end users if they want. And if there are any other hidden filters here, well, we can't see them because they're invisible. So that's a good demonstration of how locked and unlocked filters appear to end users in a Power BI report in a real-world situation. Next, let's do a quick review of numeric filters. If we select our table visual and look at the section labeled Filters on this visual, we see that we have the ability to modify the filters on our table that connect to our measures. For example, if we open our 2020 population measure and look at the options in here, we have some ability to filter the data by less than or equal to, greater than or equal to, and so forth. So let's add a filter here that only returns countries with a population between 100 million and 200 million people. Simply select greater than or equal to from the first drop-down, and then below that we'll enter 100 million people. On the second drop-down, we will then select less than or equal to, and we will input 200 million people. Then we will click Apply Filter and watch the results. Make sure also that you have selected the AND operator between the 2 parameters and not the OR operator, because you will get wildly different results if you do that. And now our Power BI table has returned all countries that have a population somewhere between those 2 numbers of 100 and 200 million. When we clicked Apply Filter, we got a list of 7 countries with populations between 100 and 200 million people in our table visual. Another note about numeric filtering that you need to know is that you cannot add measures to a page level or report level filter. It simply cannot be done. It works for visual level filters because you've already added that measure to the visual, which means that its data has already been calculated and queried from the data set. So you have a range of available values that Power BI can filter on. However, with page level and report level filters, that capability does not exist. Instead, you would need to use calculated columns, or any column that you have in your data model on one of your tables that contains numeric data. For example, if we add our land area column to report level filters or page level filters like I just did, we can use that to filter our data. So let's try to filter the land area column then by saying return all countries with a land area greater than 500,000 square kilometers. Hit Apply Filter, and we've reduced a good number of countries on our map. Let's bump this out to 5 million square kilometers, and now we're even fewer countries. We're down to just Canada, the United States, Brazil, the Russian Federation, China, and apparently Australia. So that's what we can do with a numeric column on the Filters panel. So just note that we can add numeric columns, but we can't add measures on either report level or page level filters. And if that's confusing because you're still not clear on the distinction between measures and calculated columns, go back and watch the week 1 video again where I explain the difference, or do the additional reading again. It's really important to understand that distinction when you're working in Power BI. Now, we're not working with any date or time columns in this data, but I'll go ahead and say that date columns and time columns have their own unique filtering capabilities that we'll get to demonstrate later in this course. For example, you can filter on specific dates, or you can filter between 2 specific dates. You can also enable filters that, for example, only retrieve data from the last 90 days, or the last 90 hours, or even the last 90 minutes, which is known as relative date filtering or relative time filtering. This has turned into an absurdly long video, but I also want to cover formatting options for the filter panel, because you can customize the filter panel in a lot of different ways. If you right-click on the report canvas and select Format Canvas, you'll see the options at the bottom of the formatting panel for formatting the filter pane and formatting the filter cards. If we open the filter pane options, we can change the background color, for instance, to maybe a really vibrant shade of blue, like that. And then if we're not satisfied with what the font colors look like, we can change those to white, like so. That looks pretty good. We can also change the fonts themselves, the sizes of the fonts, or we can even change the color of the search box. If you go to the input section and change that to something like gold, oh, that looks terrible. I'm going to change it back to blue. But yeah, you've got some really great options to configure the appearance of the filters panel. And when you collapse the panel like this, that nice background color is still there. And one of the reasons I like doing this is because if you want your users to actually use the filters in the report, giving the filter panel a nice bright color like this will help them see it and know that it's there. And now, next, if we go down to the filter card section of our formatting panel, we can apply different format settings to the filter cards depending on what state they are in. We have two states we can choose from in this drop-down menu at the top. Default, which means the filter has not been applied, and applied, which means that the filter has, well, been applied. And I really wish that Microsoft had made these options applied and not applied instead of default, because I think that that would have been a lot clearer. Default is not really clear exactly what it wants you to do there. I think it should be applied and not applied. But with these options, we can change how the card looks when we enable filters. So I will just go to applied and I will make a quick background color change here, moving it over to something like a light gold color. And then if I go to one of my filters and change it, let's do something like region instead. Switch over to advanced, from advanced filtering to basic and change it to Europe. We can now see that our region card, our region filter card, is shaded in light gold. Then when you're done, make sure to clear that filter by clicking the eraser button. So those are the many ways you can use filters in your Power BI reports, from report level to page level to visual level filters, working with text fields and with numeric fields, using basic and advanced and top-end methods, and so forth. Filters can be very useful in Power BI reports, but you've probably noticed a lot of ways that their functionality overlaps with the functionality of slicers. So, in our next video, we're going to go head-to-head with filters versus slicers in Power BI. Which is better? We'll look at their pros and cons and hopefully give you some idea of when it might be better to use one option over the other. Our last video was a long one, where we talked about the filters panel and the various features that it gives us in Power BI. So how does the filters panel then contrast with slicers in Power BI? When is it better to use slicers and when is it better to use filters? In this video, we'll tackle these questions. The first major difference is location. By now, you've noticed that filters can only be managed and interacted with through the filters panel. There are certain things we can do in the report canvas, like drill-through actions, that will affect the filters panel, but direct interaction between the user and the filter cards is only done through the panel. This has some benefits. For one thing, you can just collapse the filters panel if you don't want to see it, so it won't take up any space. Meanwhile, slicers can only exist on the report canvas itself. They are technically visuals, which means you have to put them onto the report page somewhere, which also means they take up space and leave less room for tables and charts and other such items. So while the filters panel can be collapsed to move it out of the way when you don't need it, slicers take up valuable real estate on the report canvas. Now, one neat trick that a lot of Power BI developers use to get around this limitation is they create what's known as a slicer panel. With a slicer panel, you can add a bunch of slicers on your page in one area. Then you can make them invisible, and you can make them visible again using a button click action. This creates a very similar experience to what we have with our filters panel. It makes it seem like your slicers in the report canvas are expanding and collapsing from somewhere. I'll teach this method in one of our week 3 videos, but it's one way that developers have found to circumvent the issue when they need a lot of slicers, but they don't want them to consume all of that real estate on the report canvas. Now, in spite of their limitations, slicers can be more powerful than filters in some scenarios. One example is their flexibility, because remember from week 1 that we have the ability to control how visuals interact with each other. With the Edit Interactions feature on our View tab, we can precisely control how each visual on our report canvas affects all the other visuals around it. That means you can have slicers that affect all the visuals on a page, or just one visual on the page, or only certain sets of visuals. Now contrast that with filters, which are limited to just 3 scopes. Visual level filters control only one visual, page level filters control everything on one page, and report level filters control the entire report. So with slicers, you can control portions of a single page. For example, we could divide a report page in half, add one slicer at the top of the first half and another slicer at the top of the second half, and then use the Edit Interactions feature to set them up so that Slicer 1 only controls the left-hand side of the page, while Slicer 2 only controls the right-hand side. This would allow us to perform a side-by-side comparison of 2 different countries from our dataset, just as one example. This is a scenario that the filters panel cannot support because report level and page level filters would affect everything on the page, and visual level filters can only affect one visual at a time. They can't affect a specific group of visuals. So only slicers are flexible enough to make this kind of report page into a reality. Here's another hypothetical. Suppose you give your users a slicer on one page, and you want the option they choose to then carry over to the next page of the report, but not to affect all pages of the report. Well, that can only be done with a slicer. You could try to do this with a report level filter, but remember that report level filters affect all pages. And in this scenario, we only want to affect the first 2 pages, but not any of the other pages. And what if you tried a page level filter? Well, that would sort of work, but if the user changed the filter on page 1, it would not affect the filter on page 2. So they could navigate between pages, but they would need to update the filter on each page. The page level filters on each page don't have any awareness of each other, so they have to be changed independently of each other. However, with slicers, we have a feature called sync slicers that allows us to synchronize a slicer across multiple pages of the report. That means you can change the slicer on page 1, then navigate to page 2 of the report, and the slicer selection will carry over from one page to the next. You can see an example of this here, where I'm looking at another report I built a few years ago. If I walk through a few pages of the report, the fiscal year slicer says current fiscal year. But I go back to page 1 and change it to fiscal year 22, and then go back through the pages one more time, that selection has carried over to each of them. This is that synchronization feature in action, and it's another advantage of slicers over filters. Now, all of these customizations you can do with slicers can become a bit of a double-edged sword. The more complex you make the logic behind your slicers, the harder it will be for your users to understand them. That's one advantage for filters. Filters are often easier to work with because they are much less complicated. Because they operate in those 3 rigidly defined scopes of report level, page level, and visual level, they're easy to understand and hard to mess up. Slicers, however, can be complicated and confusing, especially if you have a lot of them. If you do a lot of edit interactions customization with them and you use the sync slicers feature, I could definitely see a possible situation where you could lose track of what your slicers are supposed to do in your report. This adds a burden on you as the report developer to explain to your users as clearly as you can what tasks each slicer can perform. Now, I was going to tell you that slicers can't be locked, and that's a disadvantage, but that's not really true. Slicers can be placed on a report canvas and then made invisible, which prevents your users from interacting with them, which is, I guess, another form of locking them. Or you could put an empty rectangle on top of the slicer and give it a fill with 100% transparency, which would allow your users to see the slicer, but they wouldn't be able to interact with it because the rectangle would be blocking them, so to speak. So that one point is a draw between slicers and filters. They can both be hidden or locked in one form or another. I'll also say this about slicers. Sometimes they just look better than filters. Recalling the exercise that we did to end week 1, I showed you how you could create a slider control on your numeric slicer, remember? Well, that's one feature that filters don't have. Slicers appear more interactive than filters do because they have those neat little touches and because they're actually embedded in the report canvas. Put aside the fact that slicers take up real estate and look at it from a convenience standpoint. If you can stomach the amount of space that they take up on the page, slicers give you the opportunity to create really neat reports with a lot of rich interactivity that your users will enjoy if they like to play with data. For example, this screenshot shows a report I built a few years ago which allows my users to take a slider slicer to control the years of data they're looking at, similar to the one that you built in the end of week 1, while also giving them a column of different drop-down slicers they can play with to zero in on the data they want to see. This kind of visual presentation can only be done with slicers. So there are several key differences between filters and slicers in Power BI. I think if you asked me which one I generally prefer, I would tell you that I prefer slicers. They are more aesthetically pleasing, sure, but the big thing is they are far more flexible than filters are. Also, I think it's better to put your interactive filters on the report canvas next to the visuals they affect, because that should make it clearer to your users what options they have to interact with the data. Over time, I have gradually used the filters panel less and less and have generally opted for using slicers when I want my users to do their own interactive filtering. And I really only use the filters panel when I want to have filters that I can lock in place so that users can't change them. I hope this video was helpful in understanding slicers versus filters and maybe gave you some ideas for how you can use each of them in your Power BI projects. As of June 2023, when I'm recording this video, there's a new visual that has been added to Power BI in public preview that I'd like to cover. We got a glimpse of this visual's predecessor a few videos ago when we added a card visual to the top of our country detail page, seen here. We did this just to display a single value, our selected country's name, as a big title card at the top of the page. This older card visual has long been a staple of Power BI development, and I've really enjoyed using it because it's a great way to call the attention of your users to a single prominent value. However, in recent months, Microsoft announced a new initiative to reinvent this card visual, creating something that is more flexible and more visually pleasing, and what you're going to see in this video is the result of that effort. There are two visuals in Power BI that perform very similar functions. The card visual seen here displays that single value, known as a callout value, so you can prominently display that single critical piece of information, like we did with our country name here. Another good example might be a big box that tells a user you have this many days until your project is due, or you have this many dollars remaining in your budget. These are good examples of callout values. And although the card is a simple visual, it's very effective at drawing the user's attention. The other visual is the multi-row card, which is very similar to the regular card visual, except it can display multiple callout values. It's also been around for many years in Power BI, but I rarely use it because I've always found it to be inflexible and kind of infuriating. It's just, well, it's not a very good visual. I don't even bother teaching it in this course because I just don't find it to be useful. And now that we have this new card visual, well, I don't have to use a multi-row card anymore. The new card visual is designed to replace both the regular card visual and the multi-row card eventually. So if you're taking this course while the new card visual is still in public preview, make sure that you go to the Options menu inside of Power BI Desktop and then find the preview features and make sure that the new card visual is enabled. And remember that you will need to save your report and exit Power BI Desktop to fully enable the feature, so don't forget to do that. Once it's enabled and you've restarted Power BI Desktop, then let's return to our country detail page. Now, before we add the card, let's create a space for it near the top of our page. I'm going to move our chart and table visuals down a good bit on the page, and I'm going to shrink the table visual a little bit so we can create that space. Then I'm going to take our existing card visual and I'm going to restyle it a little bit by going to Format, and I'm going to remove its drop shadow and background so that now it just appears as part of our page background. And I'm doing this so I can draw a little bit more attention to the card visuals that we are about to create. Now let's add the new card visual to the page. If we go to our Visuals menu and look under the card section, gauge, card, and KPI, we'll see one that looks like the regular card visual that says 1, 2, 3, but it has this little lightning bolt on top of it. And this is our new card visual. So I'm going to click to add that. And then I'm going to resize it so that the card visual stretches from one end of our report to the other, directly below our Singapore title, our little country title card there. Now, our goal is to take each of the 2020 measures that we calculated for our countries and display them along the top of this page, so we can show these big call-out values to our users. The goal is to display these numbers so they're big and easy to find, and we're going to style them with some colors and icons that will help guarantee that our users have an easy time locating these critical pieces of data. So let's open up the object editor by clicking our little button here. And similar to a table visual, all you need to do here is just start clicking and dragging fields onto this little data area right here. Every measure or column you add to this data area will be converted into its own distinct card on the new card visual. So it's really easy to set up a nice big row of these things. So I will start with 2020 population, followed by 2020 GDP, then 2020 population density, and finally 2020 GDP per capita. Now let's make this a little bit taller so we can see the values better, and that looks good. Now let's select our new visual and check out the formatting options. The first one I'll point out is the shape settings, where we can choose between a few different customizable styles. We see rectangle, rounded rectangle, and snipped tab. Now these are all basically just variations on a rectangle. However, you can tweak some of their properties to make them look the way you want. Like if I choose this rounded rectangle style, but I don't like how rounded the corners are, I can drag this little slider over, and that allows me to tone down the curvature a bit on these rectangles, so the appearance of their corners is a little less severe. Then we can configure the callout values underneath this section. This means we can change their fonts, their colors, alignment, display units, and a lot of other properties. For example, the label portion of each card displays the name of the measure. So if we expand label, we can go down here and we can move the label position from above the callout value to below the callout value, like so. Let's go back to size and style and let's remove the background so we can see each card against our gray background. Then I'm going to change the font color of our callout values, like so. Gives them a nice blue appearance. I kind of like that. And let's maybe tone down their size slightly. I'm going to bump the font size down to 38. And I think that looks pretty good. The next thing we can configure is the layout of the cards, particularly their orientation. We have 3 orientations we can choose from: horizontal, vertical, and grid. We're currently in the horizontal orientation, which looks good when you want a row of cards that you can display across the width of the page, like we're doing right now. If you switch to vertical orientation, we can create a column of cards that also looks really interesting when you orient it like so. So we could maybe bring our cards down here, and then we could move our chart out of the way, resize that, resize the table. And this would also look pretty good. I like what we had before though, so I'm going to hit Control-Z a bunch of times and try to move everything back to where it was originally. And then let's take a look at the grid orientation. The grid layout lets you organize the cards into rows and columns. So if I put in 2 rows and 2 columns, Power BI will organize this into a simple grid. And this time I also need to shrink things down a little bit so we can see the category labels, and there you go. However, for this report, I really prefer to use the horizontal layout. So again, I'm going to hit Control-Z a few times to undo what I did and get us back to the horizontal layout. There we go. Horizontal layout. Lastly, we can configure the style of each card on the formatting panel by adding background colors and accent bars, even images, as you can see in this cards section here. Using this drop-down menu here, we can actually customize each card individually, but first I'm going to configure some styles for all of our cards. We'll begin by adding an orange accent bar to all of them. So I'll come down to the accent bar, toggle it on, and then add a little orange color here. Then I'm going to bump out the width to about 5 pixels, and that looks pretty good. We can also position the accent bar on the left, right, bottom, or top of the card, whichever we prefer. I like it on the left side, so I'll keep it there. And I'm actually not going to add a drop shadow, believe it or not, because that's what it looks like when I add a drop shadow. There's just too much space between the cards, and I don't like the way it looks. And so even though I think it is sacrilege to not have a drop shadow on these card visuals, I'm not going to do it, just because it doesn't look very good on this particular visual. Lastly, let's add some images to each of our cards. I'm going to toggle on this option, and I'm going to go ahead and for all images position them on the left side of the card, and I can't change anything else right now, so let's go ahead and start configuring these individually. We're going to upload custom images for each card using ones that are in your Week 2 exercise files. The goal here is to give a simple icon that symbolizes the data point on each card. For instance, for population, we might want to provide a silhouette of a human being. For GDP, we might want to add a stack of currency, things like that. So let's walk through how to do that. In your Week 2 exercise files, you will find a folder that contains 4 images you can add to this report, one for each of our cards here. I made these icons myself using PowerPoint for this course, and the name of each icon corresponds to the card I want you to add it to. So to get started, first go up to the top of our card section and find the series dropdown, and change that dropdown from all to 2020 GDP. This means that any changes that we make from this point forward in this card section will only affect the GDP card. Then let's go to our image section, and let's click the Browse button to browse for the file we want. Go to Week 2, then Images, and find the icon named GDP. Double-click to add it, and then, okay, it's way too big, but we can fix that by going to the Image Fit menu here and telling it to fit. All right, not bad. Now let's go back to our series dropdown. Let's change it to 2020 population, and let's click the Browse button again. And this time, select Icon Pop from our Images folder. And once again, change the image fit to just fit. And it looks good. And let's lather, rinse, repeat for population density. And one more time for GDP per capita, which looks like a little piggy bank. And there you have it, 4 cards at the top of our page prominently displaying our 2020 indicators for each country, but each card has its own custom icon. Now, icons might seem like a trivial addition to our report, but iconography is a serious branch of graphic design that plays directly into human psychology and how we interpret information. By simply adding these images to our cards, we've made it just a tiny bit easier for our brains to draw a connection between the pixels that we're seeing on the screen and our understanding of what this page is trying to tell us. We see the symbol for a stack of cash and we think, money, which is exactly how we measure things like gross domestic product. We see a human silhouette and we think person, which does a good job of symbolizing population. And as we've seen with the conditional formatting icons on our table visual here, iconography combined with colors can also quickly lead us towards certain interpretations, like green equals good and red equals bad, or green equals higher and red equals lower. So green can symbolize growth in economic output, while red can symbolize a decline in economic output. These little bits of flair, when added to Power BI reports, not only give them some nice style elements that help your reports stand out and appear visually pleasing, but they also make it easier for your users to understand the data. So that's the new card visual. As of now, in June 2023, the new card visual is in preview, and Microsoft has published a roadmap of additional features they plan to add to this visual over the next several months. So if you're taking this course sometime after June 2023, you might encounter some new or changed features. We'll do our best here at Davidson to provide some updated video content that addresses these new features as they come out. As we've been going along in this course, you may have noticed a section on the Insert tab of our ribbon that is named AI Visuals. AI, as you're undoubtedly aware at this point, stands for Artificial Intelligence, which broadly refers to the tools and techniques that we use to create computer programs capable of imitating human intelligence. For instance, generative AI has been a hot topic lately after the launch of ChatGPT, a generative AI tool that can be used to create content like text, imagery, audio, and even data based on human inputs. There are many forms of AI in the world today, and Power BI has steadily been adding AI tools to its arsenal for the past several years. Among these are the AI visuals that you see here. We haven't used any of these yet in our course, but these AI visuals are some of the most interesting visuals in Power BI, and in this video, we'll begin to explore them, starting with the Q&A visual. Q&A stands for question and answer, if you hadn't already guessed that. The core concept behind this visual is simple. You ask it a question, and it will try to give you an answer in the form of a Power BI visual that you can add to your report canvas. It uses natural language processing, or NLP, to interpret the words you give it, then compare those to the names of the tables, columns, and measures in your data model, and issue the best possible response to your inquiry. For Power BI report developers, the Q&A visual can be a fun and interesting way to build a shortcut toward adding visuals in your report. Just ask it a question, it gives you a chart, and you click a button to convert that answer into a permanent visual on the report canvas. Let's play around with this feature and see what we can build with the Q&A visual. Before we get started, I'm going to clean up our overview page just a little bit. First, I'm going to go to our table visual and I'm going to remove our Sparkline that shows the GDP annual growth because it's taking up a lot of space. And then I'm going to go to our 2020 population and 2020 GDP columns. I'm going to format them a little bit differently. With 2020 population, I'm going to change the display units to millions and add 2 decimal places after. And then with 2020 GDP, I'm going to change the display unit to billions and once again do 2 decimal places after. And see how that looks. This helps us free up some space on the page because now these columns are a little bit narrower, and now I can shrink my table down like so. Then I'm going to move our map visual over as well, and I will try to get them on an equal size. All right, looks good. Now start by going to the Insert tab, and let's add the Q&A visual on our canvas, and let's drop it to the left of our map visual. Move and resize the visual as needed so you can see everything, especially this input box at the top. This is where you will type in your questions. And below that, you'll see some suggestions that the Q&A visual gives you in these blue boxes for questions that you might want to ask. It's gone ahead and scanned your data model for measures and other attributes it thinks you might be interested in analyzing. Click the Show All Suggestions button, you can see a bunch of these things. So if we select top regions by GDP and then wait a moment, it will generate a bar chart for us that gives us a sum of our GDP measure grouped by the various regions. Now, this is a really cool feature because it just built a chart for us automatically, but this question is way too broad because it's getting a response that sums gross domestic product across all of our years from 1973 to 2021. Now, I suppose that could be useful, but I'm not sure exactly how. So let's change what we're asking by going back up to our input box, clicking the X to clear what we're asking, and let's type in a new question such as number of countries by region and see what that gives us. The result is this bar chart that shows us the number of countries that exist in each region. And so to add this to our report canvas, we can just click this small button to the right of the input box, and just like that, presto, Power BI has converted the QA visual into a bar chart, and we can place this anywhere on our canvas that makes sense for our layout. And of course, now we can also go in here and we can start formatting the visual. Of course, we'll go in and add a drop shadow, but we'll also go in and maybe customize the colors of the bars. If we go to the Show All option and enable that, we can go through and customize each color of our regions. Europe and Central Asia, Sub-Saharan Africa is gold, Latin America is orange, East Asia is bright blue, the Middle East is a dark purple, South Asia is lighter purple, and North America is bright pink. And so now the colors of our bar chart match the colors of our map visual. If I did it right, which it looks like I did. All right, cool. And let's maybe also add some data labels on here so that we can get a count of the countries in each region. So this is a quick demonstration of what you can do with the Q&A visual. Now, there are several ways we can help the Q&A visual do a better job. That's what artificial intelligence is all about. Let's add a new Q&A visual to our report canvas, and then we can open the settings of the visual by clicking the gear icon that sits in the upper right corner. You'll also see, if you're looking at the Q&A visual for the first time, a button that says Add Synonyms Now. Clicking either one of these will open up the settings for our Q&A visuals, and then we have several options that we can use. For example, by clicking the Field Synonyms button, we get this page where we can actually go in and define different words that equate to the various terms within our model. We'll open up the measures table and scroll down, where our population measure only has one word associated with it, population. But what if we add person from this list of suggestions right here? Well, that will make person synonymous with population, which might add some other options. Power BI is suggesting some things like creature and individual and soul and being, which, okay, could be, yeah. Maybe we'll add human in there next, or maybe let's try something, let's add our own suggestions such as populace and perhaps people. So we'll just click these little buttons and type in these synonyms, and there we go. We've added these synonyms to population. So now, if someone comes behind us and tries to ask a question like, how many humans live in the country of India, Power BI will know what to do with that terminology. And we can do the same thing with our GDP measure. For instance, if we go over here and say gross domestic product, which is obviously synonymous with GDP, that will add that synonym. And now Power BI is going to add some more suggestions. I don't think domestic artifact works in this particular case, but what if we do something like economic output? If we do that, Power BI will refine its suggestions a little bit, and we get something like output, which is a little bit closer, so maybe we'll add that. These synonyms will act as hints for Power BI in the future, helping it to improve its natural language processing capabilities and do a better job of answering our questions. Note that you can also set up synonyms by going to the model view in Power BI Desktop. All we need to do is select a measure or column from our model view, and if we look at the properties panel on the right hand side, we can see there's a synonyms field, and you can see the synonyms that I just added a moment ago right here in the properties panel. I'll include some links to some additional reading below this video. But overall, using this visual can be a good way to quickly produce charts and other report objects, especially on maybe a day when your coffee hasn't kicked in yet and you're having trouble figuring out where to start when visualizing some data. So my suggestion is to play around with this Q&A visual and see what kinds of things you can create. For example, try asking it questions like, give me a table of countries and regions, or give me a map of all countries, and see what results it gives you. I can guarantee you the results won't always be perfect, but you will always have the ability to go back and customize these visuals if you need to. As I start this next lesson, I'll point out a few changes I made since the end of the previous lesson. For one thing, my measures table was still showing the placeholder column, so I went to my model view and made that column invisible, and now my measures table is using the appropriate little calculator icon, as you can see over on the right hand side. Then I moved around the visuals on my overview page to make room for some content that we're going to add in an upcoming lesson. If you want, take a few moments now to update your overview page so it looks closer to mine. Now, over the last several videos, we've built a report that uses economic indicators from the World Bank that can help us answer questions like which countries had the highest GDP growth in a certain year, or which countries are considered most prosperous based on their GDP per capita. But suppose you're showing this report to somebody who isn't familiar with some of this terminology. Or suppose you're showing this report to somebody with a background in economics and they want to know where you got your data from, how the World Bank gathered this data, and how exactly each of these indicators is measured. In situations like these, indeed almost any time you're building a Power BI report for other people, it really helps to give your audience some information about the data you're presenting in case they have questions. Metadata is literally data about data. It is information that describes data, such as what source it came from, any ways it is aggregated or manipulated, or even just a description of what it is and why it's important. Metadata is often collected and stored as part of a data catalog, which many organizations use to define their various data assets. The World Bank in particular does a fantastic job of providing metadata for the World Development Indicators database, and we can add this metadata to our report using the same API that we used at the start of this week's lessons to query that information from the database and add it to our data model. And that's exactly what we're going to do in this video. To sample the metadata that we can get from the World Bank API, I'm going to use Visual Studio Code, also known as VS Code, which is a very popular development environment used by software engineers. You don't need to follow along with me here if you don't have VS Code installed. I'm just doing this so we can peek at the metadata before we load it into Power BI. Now, if any of you watching this are familiar with VS Code and want to follow along, you certainly can. Just know I'm using the REST client extension here to make these calls. I'm going to open a new editor and type in the following URL, https://api.worldbank.org/v2/sources/2/series, and I'm going to put in our series code, which is sppop total, and this is our population code. Then /metadata, and then question mark, format equals JSON. Then I'm going to highlight the URL. I'm going to hit Control-Shift-P to bring up my command palette. I'm going to find and enter the command that says REST client send request, which is visible at the top of my command palette here. This will call the metadata API and return our results, which we can see here. We get a JSON response with a bunch of metadata from the World Bank API. We can see the name of our World Development Indicators database here on line 20. And below that, there's an array called series, and then another array with our series code column. And then below that, we have a number of different attribute value pairs with names like development reference, limitations and exceptions, and source. In particular, we might be interested in this array that describes our indicator called long definition. This tells us that total population is based on the de facto definition of population, which counts all residents regardless of legal status or citizenship. The values shown are mid-year estimates. There are several pieces of metadata in here that would be fantastic to include in our report so our users can have a full picture of where the data comes from and what it means. To get a peek at our other metadata, we can copy this URL in our left-hand panel and come down a few lines and paste it. Then we'll replace the sppop total code with our ny.gdp.mktp.kd code, which is our GDP indicator. We can highlight that, hit Control-Shift-P, and do the REST client send request command one more time, and now we get a different set of metadata, this time for our gross domestic product indicator. Finally, we can take that URL and copy it and come down another line, and this time we will replace the MKTP with PCAP, which is our per capita GDP measure. Then we can highlight that, hit Control-Shift-P one more time, and send another request, and this gives us the metadata about GDP per capita. Now, we calculated GDP per capita inside of our report, rather than bringing it in from the World Bank API. But if we look at the long definition array here that starts on line 48, we can see that it tells us GDP per capita is gross domestic product divided by mid-year population, which is exactly what we used in DAX to create our GDP per capita measure. So the World Bank metadata here appears to be validating our calculation. And if we look further down at the section labeled Statistical Concept and Methodology, it further tells us that the exact indicators we used in our report to calculate GDP per capita are the ones it refers to for its statistical methodology. So we seem to be in good shape as far as how we calculated our GDP per capita in Power BI. Now, let's take each of these URLs and drop these into Power BI. I'm going to highlight the first one for population and copy it, and then I'll return to Power BI Desktop, go to Get Data, and select our web data source. Then I'm going to paste our URL into the URL box and click OK. Once Power Query opens, we are ready to start doing some JSON parsing. So I'm going to highlight this list column here and select Remove Other Columns. Then I'm going to start clicking the button in the upper right corner to expand to new rows, expand one more time. We're going to get the ID and meta type. Then we're going to expand this list into new rows. And then we're going to take these records and expand those as well. Now we're getting all of our attribute value pairs, which contain the metadata that we just saw inside of VS Code. Now let's rename this query. We're going to call it source-metadata-population, and then hit enter. Next, I'm going to right-click on that query, and I'm going to select duplicate. This will create a new query named source metadata population 2, and I'm going to right-click on this and rename it as source metadata GDP. Then I'm going to go to the data recipe for our source metadata GDP column. I'm going to find the URL, and I'm going to change the indicator code here from sppoptotal to ny.gdp.mktp.kd, which, as you recall, is the series code for our GDP indicator. Then I'll commit that change, go back to the final step in our recipe, and we can now see that this query isn't getting the population metadata, it's now getting the GDP metadata. And we'll repeat this process one more time. Let's right-click on Source Metadata GDP, select Duplicate. Let's rename this as Source Metadata GDP per capita. Then let's go to step 1 on that query and change MKTP to PCAP, hit commit, and then run back to the final step in our recipe, and we can see that we're now getting the metadata for our GDP per capita indicator. Now let's showcase another method for combining queries in Power Query. Earlier this week, I showed you how you can combine two queries using the Merge Queries feature. Well, suppose you find yourself in a situation where you want to stack two or more queries on top of each other. That's exactly the situation we're in right now. We have 3 queries that retrieve metadata from the World Bank API. And as you can see, all 3 queries have the same number of columns, with the first column having the series code and the other columns having our attribute value pairs that contain our metadata. This is exactly the kind of situation where we want to use the append queries function in Power Query, which allows us to consolidate these 3 queries into a single output. If you think of the Merge Queries feature as combining tables horizontally, the Append Queries feature is combining them vertically, literally stacking the results of each query on top of each other. Let's select one of our queries, and then let's go to the Home tab on our ribbon, find the Append Queries menu, then open it and select the option for Append Queries as New. In the window that pops up, we can select however many tables we want to append together. Now, we have more than 2 tables, so we're going to select 3 or more tables, and then we're going to find our source metadata queries, and we're going to add each one to the right-hand side here by selecting it and then clicking the Add button. Now, click OK, And this will create a new query on our left-hand panel called append1. And we can tell by scanning this table that it contains the metadata from all 3 API calls that we made. Now let's do some house cleaning. First of all, select all 3 columns and make sure that the data type is set to text. Then let's rename some columns. We'll call the first column series. We'll call the second column metadata. And we'll call the third column metadata value. Then let's rename the whole query from append1 to metadata. And then let's take each of our source queries and right-click and disable them. Now, before we load all of this to Power BI Desktop, let's take a quick sneak peek at our Query Dependencies view so we can see the diagram of what we just did. I'll switch to left to right layout, make this a little bit bigger, and then fit to screen. And then let's find our metadata query and select it to highlight where it came from. And now we can see in the green highlighted areas the 3 API calls we just made and how they're being appended together to create our new metadata query. All right, let's exit the Query Dependencies view, and then we will hit our Close and Apply button on the ribbon to return to Power BI Desktop. Once the data model has loaded the metadata table, let's quickly review how it looks in our Data View tab and in our Model View tab. In the model view, we don't need to connect this table to any of our other existing tables. It can exist on its own since we're not going to ask it to do any filtering in the report. We're simply going to present this metadata on a new page in the report so our users can review the information as needed. And that's exactly what we're going to tackle in our next video. Now that we've added our World Bank metadata to our Power BI data model, let's create a new page in our report that is specifically dedicated to displaying that metadata for our end users. We'll go down, create a new page. We'll rename this page as metadata. We'll go to our format canvas settings and give it a little light background color, just like our other pages. And then let's add a matrix visual, which is like a table, but with columns and rows that you can add data to. And then on our rows, we will have the metadata column. In our columns section, we will add the series, and in the value section, we will add the metadata value. Let's move it around and resize it a little bit. We will, first of all, turn off subtotals on rows and columns because there aren't going to be any totals. Then we will go to our column headers and we will turn off the auto size width feature. And then let's see if we can resize these columns a little bit by finding their edges and clicking and dragging. One of the things I don't like about the matrix visual is that it just does this thing where it tries to make the columns the width of the text. And in situations like that where we have a lot of text, it's, well, extremely annoying. Now, let's actually decrease the font size a little bit by going to values and putting these down to maybe size 9. And what we have now is a scrollable matrix where we can go through, and if we want to see, for instance, the statistical methodology around our population figures, we can find where our population indicator intersects with the statistical concept and methodology row, and that gives us a description of how the World Bank presents its population figures. So this is the kind of information that would be very helpful to anyone looking at our report if they want to understand how the data is calculated, where it came from, and so forth. Now, as we've seen so far, there are 3 different page types we can create in Power BI. We have standard pages, like the overview and metadata pages that we've built, plus there are tooltip pages, like the one we built in week 1, and there are drill-through pages, like the one that we have here that allows us to analyze one country at a time. Now, tooltip and drill-through pages are fundamentally different from standard pages because they are intended to present a focused view of the data using filters.
Part title.
When we hover over
around
a visual
to
to get a
Montana,
tooltip page, like
Idaho,
in week 1 when we wanted
Utah,
to see each state's population
Wyoming,
trends over
Colorado,
time, the
and watch
report
as it
sends
changes
a filter
depending on which
down
state
to
we're
that
looking
tooltip
at.
page and
Now,
says,
what if we want to
retrieve
give
the
a
data
little more
for only
detail
this
in our
state,
tooltip title?
and then it displays the
we can
page
use DAX for
inside
that.
of our
Let's
visual
select
tooltip.
our measure. But it is a highly developed industrial economy with deep ties to banks in both the United States and Europe, as well as a manufacturing sector that exports a lot of goods to Western countries.
Navigates us
Singapore's
to that
economy,
page,
as we can see from the
and
chart
it
here,
also sets
kept
filters
growing
on
in
the page
2008
so that we
and
can only see the
2009,
data for the
despite the
country
Great
we
Recession.
selected. So when you think about it, the only way you're meant to see tooltip pages and drill-through pages is through standard pages, because that's how the filters get applied. If you're a user, you would never click on these pages using the tab controls along the bottom of the report, because that would bypass the filter actions. This is why it's almost always a good idea to hide your tooltip and drill-through pages by right-clicking on them and selecting the Hide Page option. This option makes these pages invisible to your end users. It's very much like a hierarchy, where your report can have a top layer of standard pages, and then there's a bottom layer of tooltip and drill-through pages that exist as additional resources maybe that you can use to augment your standard pages. In this diagram, what I've tried to do is visualize that relationship a little more clearly. I actually like to think of it as a storyboard, and this kind of storyboarding can be very useful when you're planning a Power BI project and thinking of how you want to navigate your users through the information you're presenting. Let's notice a few things about how I've notated this diagram. First, the Start Here box represents our user's starting point on their journey through our report. They begin on standard page 1, which in the case of our economic data report would be our overview page. Next, notice I have added eyeball icons to notate pages that are visible or hidden, with the hidden pages being those that have a slash through the eyeball, much like how they appear in Power BI Desktop. Now the arrows. These solid black lines with arrows that connect our pages are meant to represent basic navigation between visible pages, while the dotted lines with arrows are meant to represent special navigation that connects us to hidden pages, that being our drill-through actions and our tooltip visuals. Now, notice the orange filter icons that exist above the bottom layer of tooltip and drill-through pages. These help us remember that these pages are filtered by the pages they are connected to. Finally, note the directions of the arrows on the lines that connect each page. The lines between our standard pages are all pointing in both directions, which indicates that we should be able to navigate back and forth between them. Meanwhile, the dotted line from standard page 2 to the tooltip page only points in one direction to indicate that the tooltip page is only visible from inside standard page 2. And lastly, the dotted line between standard page 3 and the drill-through pages point in both directions. This is because when we create drill-through pages, we need a way to navigate our users back to the pages they came from. That's why Power BI automatically created this back button on our country detail page earlier in our lessons. So, returning to our countries report, how can we implement a system like this? Well, first of all, we make sure that any drill-through and tooltip pages that we have are marked as hidden. Then, when we return to the overview page, let's go to our Insert tab and find the option for Buttons. And if we open that menu, we'll find an option towards the bottom called Navigator. If we hover over that, we get two options, Page Navigator and Bookmark Navigator. We haven't covered bookmarks yet in this course, so we'll come back to that one. For now, let's select the option for Page Navigator and watch as Power BI adds a new object to our report canvas, which lists all of our pages as clickable buttons. First, notice that the button navigator is showing our hidden drill-through page, and remember that we don't want users navigating to the drill-through page with that method. They need to get there by using the drill-through action on our overview page. So let's go to our format settings for the button navigator, and then let's find the section named Pages.
and look at the two subsections here. The option to show hidden pages is enabled, so let's toggle that off, and now the drill through page is no longer visible in our button navigator, which is good. While we're here, let's explore formatting options for the button navigator. In the section labeled Grid Layout, we can choose between horizontal, vertical, and grid layouts for our button navigator, just like when we created our new card visual a few lessons ago. Then, if we go to our Shape section, we can choose from a variety of shapes for our buttons. It defaults to a basic rectangle, but we can also try some other options, like maybe a rounded rectangle, which looks okay, or we can go choose something a little bit different, like a pill icon, which just looks like a slightly more rounded rectangle, or we can add something like a parallelogram, which, now I think about it, that looks pretty cool. Now, if we select this and go further down to the Style section, we also can configure how the buttons appear based on their state. When we open this menu, there are 4 different states to choose from. Default refers to how the buttons are styled when they are not selected. Hover, which refers to how they are styled when you move the mouse over a particular button. Press, which is how they are styled when you are actively clicking on a button, and Selected, which is how the button appears when you are currently on the page it represents. So if we go back to our button navigator, the overview page is selected because it is the one that is shaded in black. So let's go through and change each of these. I'm going to start with the Selected option, then go to the Fill settings and change the color from black to, let's say, dark red. And now notice how our overview button is now shaded in dark red. Now let's go up and select our hover state from the menu. And let's change this one to a light blue color, like this. Now if we go back to the button navigator and hover over metadata, you'll see that it shades in light blue when my mouse goes over it. Finally, let's go back to our menu. Let's select Press from the menu, and then let's change the fill color on the press action to a light red or pink. Then if we click the metadata button here, it turns red or light pink when I click on it. Now you might be wondering why clicking the button didn't take us to the metadata page. That's because when you're working inside Power BI Desktop, you need to use Control left click to engage button actions. This is exactly the same as what I told you when we created the drill through page a few lessons ago, and Power BI automatically created that back button for us. Inside Power BI Desktop, we have to use Control left click to engage these actions. But once the report is published and your users begin interacting with it, they won't need to do that. They can just do a simple left click. So last thing before we wrap up, we need to add the button navigator to all the pages where it should be visible. In this case, we are talking about our overview page and the metadata page. So let's select our navigator, then let's use Control-C to copy the object, then navigate to our metadata page and use Control-V to paste the object. And this may require us to move and resize our matrix visual a little bit. Now we have our button added to both pages, and if we use Control-Click, we can navigate back and forth between the overview page and the metadata page, like so. Noticing how the color of the buttons changes based on whether we are hovering, pressing, and whether they are unselected or selected. So why add page navigators in the first place when our users can just use the tabs along the bottom of the report canvas? It's kind of the same reason I articulated a few videos ago when we talked about the benefits of using slicers instead of using the filters panel. It's a better user experience this way. By putting these objects inside the report canvas, you can keep your user's attention focused on this one rectangular area, our report canvas, giving them a one-stop shop for navigation, filtering, and all of the information that they're looking for. Plus, as you saw a moment ago, the page settings on the page navigator allow us to get very specific in selecting which pages we want to show. So using the navigator gives us more flexibility than we would get if we used the buttons along the bottom of the report. As an example of what you can do with page navigators, here is Davidson College's Fact File report, which is a Power BI report I built that we make publicly available to anyone visiting our website who wants to learn key facts about our institution. The buttons along the left-hand side are a single page navigator that takes users through the report page by page, which I think creates a nice experience, almost like they're inside of an app. On a couple of these pages, like this one, you can also get a sneak peek of a bookmark navigator in action, which allows me to navigate my users between different preset bookmarks inside of that particular page. Okay, now that we've added some page navigation in our report that allows users to easily find the metadata, in the next video, we'll talk about how to bring all of this together and create an end product that is intuitive and informative for our audience. So far, the report we've created consists of some great visuals and interactivity, like Sparklines and conditional formatting, a button navigator, drill-through actions, cross-filtering visuals, all of that cool stuff. But it's also incredibly beneficial sometimes to add text to our report that gives our audience some clues as to what they're expected to do with the data, or to provide links to where the data even came from. The metadata page that we created presents some great info about our indicators, but there's more that we can do here to guide our audience through this report. First, we should give our report a title on the overview page. Maybe even a subtitle too, some text that identifies this report and its purpose. And also, we might want some text that tells users that there's a drill-through action that they can take. So we will begin by adding a text box, and then we will click and drag it to the upper left corner of our overview page and resize it. Then I'm going to go to size and style. I'm going to turn off the background. So this is just going to be some text that is displayed on top of our light gray background. Notice that there is a set of editing controls that appears to the right of our text box editor. This will allow us to select a font, font size, font colors, font layouts, really everything font related. Plus we can insert links, and we can even insert dynamic values from our data set using this little value section right here. Now let's click into our text box, and then I'm going to add a large title, let's say maybe 24 size font, and we'll say this is Global Economic Indicators. Tell you what, I'm actually going to switch that from Sego UI to Sego UI Light because I always like lighter fonts. And then let's come down a line and let's add a subtitle, this time in a smaller font. I'll go with something like Sego 12. And then we'll say use yearly data from the World Bank, worldbank.org, to analyze world countries by their population and economic output. And then we'll say right click on a visual and use the drill through feature to see detailed data about a country. All right, I'll crunch down that size just a little bit more so it doesn't put a scroll bar in there. And then I'll also highlight this sentence and put it in bold and maybe give it a little underline so that our users will notice it. Next, let's go to the metadata page and let's do the same thing. We'll add a text box. We will click and drag it into the upper left corner and resize it. We'll remove the background and we will add another title, Sego UI Light, size 24 font, and we'll call it metadata. Now this is going to interfere with our matrix visual, so I'm going to bring this down towards the bottom of our page like so. And then let's actually resize this a little bit. I'm going to make it even bigger. Come down a line. Let's go to Sego UI, size 11 font. And then we're going to add some more information here. Use this page to explore metadata about the resources used to build this report. Now let's come down a couple more lines and we're going to write a section called data sources. We'll say all data in this report comes from the World Bank's World Economic Development database at, and then let's insert a little link here. We'll click insert link. We'll add a URL for databank.worldbank.org. Then click done, and that will add our URL. Now let's actually shrink our matrix down a little bit more and then let's expand our text box. I'm going to come down and I'm going to add another section here, which I'm going to call specific API data sources. And in here, I'm going to add a bulleted list with each of the URLs for our APIs, starting with countries, then our population metadata, our GDP metadata, and GDP per capita metadata. And if you want to know where you can get these URLs pretty easily, just go to the Home tab, go to Transform Data, and then in that menu, select the Data Source Settings. This will give you a pop-up window which shows every data source that we have used so far for this report. And what you can simply do is right-click on one of these URLs and say Copy Path to Clipboard, then close and paste it inside of your text box. Simple as that. I'm going to come down a couple of lines and do yet another section. And this one I'm going to call Report Author. Make sure that text is in black though, because apparently Power BI wants to put it in blue for me. Then come down and I'm just going to put in my name right here, Pete Benbow, and email. This way, people know how to contact me if they have any questions about the report. Then let's make sure that our font sizes are consistent because they don't look consistent to me right now. So I'm going to highlight everything and I'm going to change it to a size 11 font. There we go. That looks a lot more consistent. Now, if our users want to get to the metadata matrix, what they can do is they can just go to the focus mode right here. Clicking that will open the metadata catalog, as it were, in this, and then they can go back to the report. So what we might want to do to direct them to that is to add another text box, and we'll just crunch it down here to about the top of the matrix. We'll get rid of the background, and we'll say to view the metadata in a larger format, use the focus mode button on the matrix visual below. So now they get a little text cue that they can use to know that if they just hover over this and click on focus mode, they can see the whole metadata catalog for our report right here. Lastly, let's add some titles to our visuals if they don't already have them. This not only clearly articulates the purpose of each visual, but it also works in your favor if your end users try to export data from any of your visuals, because the name of the resulting file that they export will default to the title that you set. So if we start with our metadata matrix, we can turn on the title and we will call this Report Metadata. Now, if we click on the More Options and Export the Data, Power BI will export a CSV of the metadata called reportmetadata.csv. All right, see how that works? So now what we can do is we can go to our other visuals on the report and change their titles as needed. We'll go to our countries, turn on the title, and we'll simply call this Countries. Then we'll go to our map visual, and we'll call this something like World Map, because what they had before was not exactly the greatest title. And we'll go to our bar chart, and we will call this Total Countries by Region. So, by adding just a little bit of text in a few places in our report, we've given our users some helpful clues about how this report can be used, including where the data comes from, and even how to do specific actions like drill through and focus mode. There are probably additional things we could have done, like adding some text to the country detail page, but I think you get the point. It really behooves you to add this extra documentation to your Power BI projects, so I encourage you to continue doing so throughout this course and as you begin using Power BI professionally. A few lessons ago, when we added icons to our new card visual, I had 4 icons that you could import into Power BI Desktop from the exercise files. In this lesson, I'll show you how to quickly make your own icons for adding to your Power BI reports using Microsoft PowerPoint. The process is really simple. First, just open PowerPoint and create a blank presentation. You'll hear me refer to PowerPoint presentations as PowerPoint decks as well, so just keep that in mind when I refer to a PowerPoint deck. I'm talking about a presentation. And then with this blank slide in our PowerPoint deck, let's remove any text boxes on the slide. Then let's go to the Insert tab on our ribbon, find the option for Icons, and select it. This will connect us to Microsoft's online repository of icons, which is available for pretty much all Microsoft 365 products, I think. I've definitely used it in Excel and PowerPoint at least. And from here we can select a number of icons that we might want in our report. There are different categories that we can look at, such as technology and travel. Interface is a favorite one that I like to use. But for the icons that we did for our country detail page, I did a keyword search for, first of all, money. And this allowed me to get the cash and piggy bank icons that we used for that visual. And then for the population figures, I just searched for the keyword people. And once I had the results here, I could get our icons for population density and just regular population. And now when I click the Insert button, all 4 of these icons get added to my PowerPoint slide. And then I can just click and drag to rearrange them. And then I can begin styling them in whatever way I want using the Graphics Format tab on our ribbon. So I'm going to select all of our visuals, and then we'll just tweak them a little bit. We'll add a different fill color like green, and then maybe we'll add a drop shadow, of course, on all of these just to give them a little bit more depth. And then when we're done tweaking the style, all we have to do is select one of these images, right click, and go to Save as Picture. We then get to pick the folder where we want the file to go, and we get to select the type. Currently it's defaulted to SVG or Scalable Vector Graphics, but I've noticed a slight bug perhaps in the new card visual that doesn't render SVGs correctly. So I'm going to choose the Portable Network Graphics or PNG option instead, and I'm going to call this piggybank.png. I'll click Save, then go to Power BI Desktop, select the card visual, go to the format settings, make sure that we have selected the 2020 GDP per capita card from the card section, then go down to Image, get rid of the original icon, then we'll go to Browse, select piggybank.png, and then let's make sure that we have it set to fit instead of normal, so it's the same size as the other icons, and there we go. We've added our custom icon from PowerPoint directly into Power BI. And it looks okay. I think I actually prefer the old icon better, to be honest with you. So let's look at another way to do this then. Suppose that I want to add a background to my icons. Now currently this one is just kind of on its own with a transparent background, but if we get rid of the drop shadow first of all, we can use the Insert tab to create shapes in PowerPoint, like a circle. I'll draw a circle really quickly. I will use the shape format settings to make sure that the circle is a perfect circle by making sure that the height and width are the same, 1.5 inches on both sides. Then I'll maybe resize my icon a little bit, make it slightly larger. And then we can just drag and drop it onto the circle. Now first we need to make sure that the icon is above the circle in the layer order. As you can see right now, it's obscured by the circle. But if I go to Graphics Format and then select Bring Forward, I can bring the icon forward in the layer order so it sits on top of the circle. Tweak the graphics fill. This time let's make it white. Then let's size it down just a bit. We'll use the alignment features in PowerPoint to make sure that it is aligned to the center of the circle, like so. Move some of these things out of the way. And then on the circle itself, we can do some things like getting rid of the shape outline, which I don't like. And then maybe on the shape fill, we can add a little bit of a gradient here to make it seem a little more interesting. So we'll just do kind of a, there we go, just a little left to right gradient to make it look nicer. And then when we're ready to save this, all we have to do is select both of the visuals. We can select the icon and then Control-click to select the circle, and we'll right-click once more, Save as Picture, and we'll call this piggybank2.png. Now we go back to Power BI Desktop, select our card visual one more time, make sure we're on that 2020 GDP per capita series, then go down to Image, get rid of the original piggy bank, Browse, and select piggybank2. Once more, make sure that we select the fit right here, and now we've added our custom icon number 2 to our Power BI report. And it really is that simple to create your own icons. Now, using PowerPoint to create icons is just the quick and easy approach. There are other tools out there that some Power BI designers use that are much better, but also more expensive. But if you're looking for a way to rapidly create some simple icons for free using Microsoft tools, I think you'll get huge dividends from just building a library of icons in PowerPoint using the methods that I've shown here. Another interesting use for Microsoft PowerPoint in the world of Power BI is to generate report backgrounds. So far in this course, we've just been slapping a plain light gray background like you see here behind each page of our reports. But you can and should get more creative with this. One way to experiment is to fire up PowerPoint and play around with the design features inside, because this will allow you to quickly generate some interesting and stylish backgrounds that can give your report a sleek, professional appearance without distracting your audience from the report content. In this lesson, I'll show you some methods for doing this. First, let's go to PowerPoint and open a blank presentation. Then, if we remove the text from the blank page like we did in our last video, and then go to the Design tab, we can see that there are a number of themes for us to choose from here. I'm going to navigate down to this menu and find a theme that I like, which this looks pretty good. I'll just select this. It's a little blue gradient background. And then we can even select from some different variant colors on the right-hand side over here. Like we could do orange or purple. Purple looks pretty good. Blue looks good. They all look pretty good. Then once we've found a particular background that we like, we can just go to File, Export, and then change file type and save as another file type. Save this particular PowerPoint slide as an image. I will save it as a PNG file, just like we did with our icons, and I will call this edxbg1.png. Hit save. It will ask us which slides do we want to export, and there's only one slide here to choose from, but I'll just go ahead and say just this one. And that's going to export this slide as an image. Now I can go back to Power BI Desktop, go to our canvas background settings, and instead of a background color, I'm going to choose to upload an image, and then go to our week 2 folder, find edxbg1.png, and add it to our report. Now this is going to require us to make a few style changes, so first thing I'm going to do is go to our text box and change the font color from black to white. And all right, we're already looking a lot better. But a couple of interesting things that you can do in a situation like this is you could add some transparency to your report visuals. For instance, if I select our world map and go to size and style and remove the background, well, now we've got a world map that sits on top of that. And that looks okay, but if we do something like maybe add the background in and then up the transparency a little bit to say 50%, maybe a little bit more, then we almost get a frosted glass kind of appearance here. So if we take that same setting then, we've got a transparency of, let's say, 75%. We can take that and apply that to our bar chart as well. We'll set a transparency of 75%. Now the table is a little bit trickier. When we select the table, the best way to do this is going to be to go to the style presets and turn off styling. So we're going to set the style preset to none, and then we can go in and turn off the background. Now we're still going to need to make some changes here. Obviously, we'll go to values and we'll set the text color to white for both text color and alternate text color. Then we can go to our column headers, make these white as well, maybe even make them bold so they're easier to see. Now the only problem we have is that our conditional formatting on the population density column doesn't look so good. So we can go in and change that by going back to our visual settings and editing the conditional formatting. What's probably going to be smartest based on our color scheme is to pick like a light orange on the low side and then a much darker orange on the high side. Click OK, and then go to the specific column settings, find our 2020 pop density column, and change the text color to black. And that might look a little bit better as far as our conditional formatting goes. Oh, the other thing I need to do, go back to size and style. Don't turn off the background, but maybe set it to, once again, 75% transparency so that we've got that sort of, once again, frosted glass appearance. And go back to the title and change that to white. All right. So that's not bad. I actually really like the way that looks, and that's an example of something you can do pretty quickly and easily in Power BI. The only other thing I don't like is that our spark lines are getting a little bit washed out by that lighter color. So again, let's select our table, go to the Sparkline settings, and then we'll change the data color to maybe a darker blue, like that. All right. Again, looks pretty good. So those are some things that you can do with a custom background from PowerPoint inside of Power BI. Now, these kinds of things represent, in my opinion, the bare minimum of what you can do with PowerPoint. You can use one of Microsoft's themes, export it, and upload it to Power BI Desktop, then tweak your visuals to make everything look good. Microsoft has a lot of good-looking themes to choose from in PowerPoint, so you just need to explore that application a little bit and find the ones that you like best. Now, another option that I like to use is to not bother with any of the themes, but to actually create your own theme using simple shapes on a blank PowerPoint slide. So to demonstrate this, I'm going to use the blank office theme here in PowerPoint, and I'm going to add a few objects by going to the Insert tab. Let's add a shape, be a rectangle. I'm going to draw this rectangle along the side, and then I'm going to drag it here, and I'm going to extend it a little bit beyond the boundaries of the page, because sometimes when you have an object that sits right at the boundaries, you get borders and so on and shadows that don't look particularly good when you export. So this will make things a little bit better. I'm going to remove the shape outline. I will add a little bit of a gradient here just to make this look more interesting. Generally something I like to do. That looks pretty good. Then I will add another rectangle along the top. And this is going to be sort of where our title and subtitle can go. I'll drag this across, and this is going to overlap our sidebar. I will give it a nice, really dark color. Once again, I'll give it some gradient just to make it look more interesting. And then in our background, I'm going to right click and go to Format Background, and I'm just going to choose a simple light gray color. Now the next thing I want to do is I want to try and create some objects on this page that can align to our visuals from our report here. So for instance, if I want to create a little section for our table visual, I can go and create another shape. This time I will select a rectangle with rounded corners, and I can bring it onto our PowerPoint slide and size it appropriately like that. And then we'll just maybe drop a white fill on it and remove the shape outline. No outline, but we'll give it a little drop shadow just to add some depth to our design. And then also, I don't like the severity of the rounding of these corners. So to fix that, what I can do is I can find this little yellow circle right here on our rectangle. And I can just click and drag it to the left to just kind of smooth out that rounding a little bit. And I think that looks a lot better. It just doesn't look as severe as the other way that we had it. Then I can take this design, select it, copy and paste. Bring my pasted object over here, resize it, crunch it down a little bit over here, resize some more, copy and paste, bring that here, and make sure everything is nice and aligned. And there we go. I've got areas for my visuals to go to. So now I can File, Export, change file type, Save As, and I will once again save this as a PNG file. I will call this edX-bg2.png. Select just export this one slide. Then we can go back to Power BI, get rid of background 1, click the Browse button, find background 2, and drop that on here. And now all we need to do is just resize our visuals and reformat them so that they fit into these areas that we created. So with our table visual, I will select it. I will click and drag the corners so that they fall within the boundaries of this little rectangle that we created. Then I'm going to go to Style Presets and just set it to default to get us back to at least something that looks normal. Go to the title, change that to black, and now we can see our countries table inside of the boundaries of that. It looks okay. That's a little bit of it's hanging over a little bit there in the corner. Let's also make sure that there's no drop shadow here because we don't need a drop shadow because it's in the PowerPoint background. That looks pretty good. Same thing with the world map. We'll bring this down. We'll resize it a little bit. We will remove the drop shadow. We will remove the background. And I think that's all we need to do with the map. And then with the bar chart, we'll once again do the exact same thing. Just bring it in, resize it, remove the drop shadow and the background because we don't need those. We'll go back to the y-axis and x-axis and title, and we'll just change those text colors back to what they were before. And there we go. That's an example of how you can just build your own custom theme, your own objects inside of PowerPoint, and then add them to your Power BI report. Now, this approach does require you to think carefully about how many visuals you need on each page and how they should be sized. Obviously, if you decide to make changes after this, you will need to reopen PowerPoint and move things around, and then re-export the file from PowerPoint and re-import it into Power BI Desktop. And that can be a really tedious process if you do it a bunch of times. So I recommend that you wait until you have settled on a general layout for your report page before you begin this process of creating a custom background in PowerPoint, and that should save you some time. Also, be sure to save the PowerPoint file somewhere so that if you ever need to make changes to the layout, you can just reopen the PowerPoint. And once you've settled on a general theme in your PowerPoint deck, you might also consider creating several different layouts based on that theme using different slides in PowerPoint. For instance, you might duplicate this, and then we can split this into a 4-quadrant layout where we have one visual here, another visual down below, get them all aligned, and this could be yet another one of your layouts that you can export from the PowerPoint deck. You might want another situation, if we duplicate this slide, where we have a slicer panel over on the far left side that extends along the height of the page and contains all of your slicers. Then we can just add a couple of visuals in here and make sure that everything is aligned. Almost got it. There we go. And this is yet another template that you can use. Or you might want to put slicers along the very top. So we can duplicate that, take our slicer panel, move it up, and we can have a long row of slicers available right here at the very top of our report if you'd rather use that kind of layout. So there are a lot of different ways that you can use PowerPoint to create Power BI backgrounds that are customized to your needs, and then just save the PowerPoint and use it as a reusable library of Power BI backgrounds that you can rely on whenever you're building reports. This could be a really good way to create templates that you use in your organization. You know, work with your team to design a template that everyone agrees on that uses your logos and your color schemes and everything else that you need, and then save that somewhere where everyone can access it. And then they can just go through and use the template over and over again as you create new reports. It's a pretty good way to do things when you think about it. The main thing you'll want to avoid when adding custom backgrounds like this is distraction. It can be very tempting to add a report background that's visually very interesting and then slap some visuals on top of it and make them transparent like we did earlier so that you can see the background through the data. But I caution you against this because sometimes if your background gets too busy and too interesting, you're going to be sending a lot of information to your users' brains at that point. Their minds will need to work that much harder to separate the relevant information in your visuals from all of the noise and clutter and shapes and colors that are in your background. And this is another one of those cases where Power BI design meets up with fundamental principles of human psychology and how our brains interpret information. Minimizing that cognitive load on your users is an important aspect of good report design, because remember that your goal in building the report is to convey the information that's in the data, and your background should help you accomplish that goal, or at the very least, it shouldn't hinder you from accomplishing that goal. For example, I think that this image from PowerPoint is really cool and interesting. I love the geometric sort of idea and the colors. It kind of reminds me of like a cyberpunk theme. It looks very, futuristic and vaguely techy, but also in kind of a retro 1980s way. It's very interesting. But if I export this and put this in my Power BI report, I'll go and save it as a PNG one more time, and we'll call this Power BI cyberpunk.png, right? Just this one. And then we go back to our Power BI report, and let's get rid of our background, browse, and select Power BI cyberpunk. When we add it to our report, it's actually kind of visually distracting. Even if I turn off the transparency on our visuals, like adding our backgrounds back and setting them to 0%, on both the map and the bar chart, there's still these lines in the background that you can see and that are a little bit distracting from the actual content of the report. So we still have a lot of what I call background noise in the report canvas that's basically yelling at our users, trying to get their attention. Hey, look at me. Don't look at the data, look at me. And you should never want your background to attract more attention from your users than the actual data. With the background objects, you want to err on the side of subtlety, really. You want your users to look at the report and think to themselves, okay, this is a really interesting story. Or, what questions does this raise for me? Or, hey, I need to make a decision on this. Then, maybe at the tail end of the report, they can think to themselves, hey, this looks really nice. Good design. But it should be an afterthought in the literal sense of the word. What you don't want is for your users to open the report and the first thing that goes through their head is, wow, that's really beautiful, or wow, that's really overwhelming. Because at this point, you're getting them to focus too much on style and not on substance. The substance being the data. The data is where the stories are, and that's where you should focus your users' attention. So resist the temptation to build flashy, grandiose reports with distracting features in them. And when in doubt, don't be afraid to just go with a plain background, like we've been doing so far in this course, especially if you're working on a prototype or version 1 of a report, because at those early stages, it's much more important to get the story right than to impress your users with how great of a graphic design artist you are. While I'm on the topic of report backgrounds and icons, another tool that you should check out is Figma. Figma has become increasingly popular among Power BI designers for creating and sharing some really world-class report interfaces. If you go to the Figma community and search for projects that are tagged with Power BI, you'll find dozens of examples of some really slick designs that you can access through Figma or purchase from the people who made these designs. And these kinds of things can really set you apart as a Power BI developer. So I'll include some links below this video for you to check out. One of the things we mentioned in week 1 is the fact that your Power BI report is composed of 2 main components: the report itself, which contains all of your visuals, and the underlying data set, which contains all the information that has been loaded into your data model. It helps to think of these as layers, so that's how I'll refer to them: the report layer and the data set layer. And you hopefully recall me saying that the report layer communicates back and forth with the dataset layer using the DAX language. As you create new visuals and interact with them, Power BI is retrieving the data for those visuals by building DAX queries behind the scenes, then sending those queries from the report down to the dataset. The dataset engine then calculates the results of the query and sends those results back to the report, where they are rendered inside each report visual. So even though you and your users can't see it, there's a lot happening behind the scenes when you interact with a Power BI report. And there's a lot that can happen in these processes that can slow down the performance of your report. Badly optimized DAX can take a long time to query and return its results from the dataset. A visual that contains too much information can take a long time to render. Or you might be using a data source that's badly optimized, like a database or a data warehouse that needs to have some index tuning done to it. And that's a shout out to my fellow database administrators. Any of these factors and more can incur a cost on the performance of your Power BI report. But how are you supposed to know what's causing the issue? Well, Power BI gives us a way to create a log of these various processes so we can detect performance issues and hopefully resolve them. To see these processes in action is really simple. We're going to go to the Optimize tab on our ribbon in Power BI Desktop, where we'll find an option called Performance Analyzer. When we click this button, a new panel appears on the right-hand side of Power BI Desktop. The Performance Analyzer works by recording diagnostic information about your report as you interact with it. That means every button click on a visual, every page navigation, every tweak to the data model, all of these various actions that you can take in Power BI Desktop will be recorded in this panel. Let's experiment. First, turn on the Performance Analyzer by clicking the button that says Start Recording. From this point forward, anything we do in Desktop will be recorded, so let's start by hitting the Refresh button on our Home tab, which will refresh the data set from our API endpoints and our CSV file. And we can already see some activity in the Performance Analyzer panel. Next, let's navigate to the metadata page, and we get some more activity. Then let's go back to the overview, and let's start cross-filtering some of our visuals. I'm going to select Sub-Saharan Africa from our bar chart, and then I'm going to unselect it. And then let's scroll down through our table visual for a while and watch as more activity is being populated inside of the Performance Analyzer. So at this point, I think we've gathered enough data. Let's click the button on the Performance Analyzer to stop recording. And then let's look at the results that we logged in our panel. The actions that we took, such as refreshing the data set, changing pages, and cross-highlighting or cross-filtering our visuals, are all captured here. And underneath these actions, we get a list of the objects in our report that were affected by our actions. The right-hand column in the panel records the number of milliseconds that it took for each visual to refresh its data after the interaction happened. For instance, when we first clicked on our bar chart, it took the world map visual 437 milliseconds to refresh. And if we expand that row inside of the panel, we can see three different rows underneath: DAX query, visual display, and other. The DAX query portion represents the combined time that it took for our chart visual to send its query to the dataset and for the dataset to return the result. The visual display portion represents the time it took for Power BI to render our map after the data was retrieved. In other words, this is the time it took for Power BI to draw the pixels on the screen so that we can see them with our eyes. And finally, the other portion is a catch-all for other operations that need to occur, such as the visual needing to prepare its query before it sent it, and needing to wait for other visuals to finish loading before rendering the data. So you can see how the Performance Analyzer captures all of these background processes and the time they take to complete. And this all happens at a very fine-grained level. This gives us the ability as report designers to identify any bottlenecks in our report performance. For example, if our report becomes slow and we want to figure out why, we can turn on the Performance Analyzer and create logs like these, and then look for the processes that are taking too long to complete. Maybe a particular visual is trying to display too much information, which is causing its visual display time to increase. Or maybe we have a measure with some poorly written DAX that is taking too long to query the underlying data set, so the DAX query time is slowing down. These are common scenarios that can degrade the performance of your Power BI report, and we can capture these kinds of events in the Performance Analyzer panel, which helps us know what we need to fix. In our next video, we'll take some of the output of the Performance Analyzer and use that to analyze how DAX queries work. In our last video, we used the Performance Analyzer in Power BI Desktop to log the processes happening behind the scenes as we interacted with our report. Now, let's take the output of those logs and examine one of the core components of Power BI architecture: DAX queries. So far in this course, we've only used DAX as a way to write measures. Those measures, as you recall, get stored in our data model as text formulas. To borrow a term from an earlier video this week, these formulas are metadata that is stored in our model, and they only get evaluated once we add them to visuals like charts and maps and tables and so on. We've also discussed the fact that visuals in the report layer communicate with the report's underlying dataset via DAX queries, but we haven't actually shown what this looks like. The role that DAX plays in governing the give and take between the report layer and the dataset layer is much bigger than the one it plays in defining our measures, but you don't see it occurring on the front end of Power BI Desktop, so it's easy to not even be aware that it's happening. Returning to our Performance Analyzer panel, I have hit the clear button to clear the results from our last lesson, and I'm going to start recording again so we can create some new logs. Once we've started recording, I'm going to right-click on an interesting country somewhere, like Norway for instance, and then go to the drill through option and drill through to our country detail page. As soon as we do that, we've captured some new logs in our Performance Analyzer, so I'm going to turn off recording by clicking the stop button. In our log, we have a single action, changed page, and below that we have the list of objects that were loaded on our country detail page when we performed that action. Let's open this section for our GDP annual growth chart right here. We can see from this that it took our DAX query 15 milliseconds to run, and it took our visual display 92 milliseconds to render, and then 519 milliseconds were devoted to other mysterious things happening in the background. But directly below that, we see the Copy Query button, which we can use to copy the full text of the DAX query to our clipboard. I'm going to click to copy it, and then I'm going to go to my External Tools tab on my ribbon, where you'll see I have an option here called DAX Studio. This is a free download for Windows that will show up in Power BI Desktop after it's been installed. To get DAX Studio for your machine, simply go to daxstudio.org. It provides a graphical user interface for writing DAX queries against Power BI datasets, which is helpful for a lot of reasons, especially for more advanced Power BI developers. In our case, we're mainly going to use this as a way to look at this query and what it's doing. When we open DAX Studio from inside a report in Power BI Desktop, it's going to automatically connect to that report's underlying dataset. That means even though DAX Studio is a different application than Power BI, they're still talking to each other. For my fellow database developers out there, this kind of makes DAX Studio somewhat analogous to the SQL query tools that we commonly use, like DataGrip or Toad, Azure Data Studio, and SQL Server Management Studio. Now notice on the left-hand panel of DAX Studio there's a tab called Metadata, and in that tab we can see a drop-down that has a random string of numbers and characters in it. This is an identifier known as a GUID, G-U-I-D, or a globally unique identifier, and it represents the connection to our Power BI dataset. Below that, we have a searchable list of all of the tables, columns, and measures in our dataset. Now we can go to this DAX query editor here, and we can paste the results from our Performance Analyzer into this window. So what you see now is a DAX query in all of its glory, and you'll see some familiar aspects here, as well as a lot of new ones. First of all, we've got one of those double slash comments on line 1, and from lines 3 to 15, we have variables being defined. The first variable uses a DAX function called treatAs to filter our countries table on Norway using the ISO 2 code column. The second variable then comes along and uses the summarize columns function to retrieve the first variable and then adds our GDP and GDP annual growth measures from the measures table. This summarize columns function calculates a new variable which is known as a table variable, and then this will be used further downstream in our third variable. That third and final variable then processes the results of the second variable using this sample function. Essentially what it's doing here is imposing a limit on the amount of data the query can return. It's doing this to avoid performance issues that might be caused by the query either returning too much data or the visual attempting to render too much information, either of which could substantially slow down our report performance. Next, on line 17, DAX uses this evaluate keyword to return the output of the third variable, And then on line 20, the order by clause tells the dataset that we want to sort the data by year in ascending order. And if we run this query in DAX Studio using the Run button, we get a glimpse of the raw data as it looks when it is returned from the dataset to the visual. We can see every year of GDP data for Norway sorted in ascending order by year. So that's a quick glimpse of a DAX query as it is generated by your Power BI report. We're not going to mess with writing DAX queries in this course, so don't be worried that I'm going to quiz you on how to write one like this, because that's not going to happen. This video was largely just to show you how Power BI communicates between the report layer and the dataset layer, which is a critical part of understanding Power BI as a product. But as you journey deeper into the world of Power BI, especially if you start to develop paginated reports, the ability to write DAX queries like this one will almost inevitably become part of your skill set. And if you get to that point, DAX Studio is one of the most important tools you can have. It makes the process of writing DAX queries far easier, so I encourage you to download it. If you missed the link earlier in the video, I'll include it below. So I just showed you how you can use the Performance Analyzer in Power BI Desktop to look at how your DAX queries might be slowing down your report. But what about Power Query? Is there a way for us to analyze performance data when it comes to how long it's taking to import from the data source into our tabular model? The answer is yes, and you may have come across these features on the Tools tab of the Power Query editor already. They're called Power Query Diagnostics, and we can use them to analyze either a single step in one of our queries, or we can analyze the entire set of queries all at once. Let's explore how to do that with our global economy data. First, I'll ask you to recall the lesson from earlier this week where we discussed referencing queries and duplicating queries. And remember what I said about the misconceptions around using the reference queries feature. When you use reference, that upstream query is not being executed only once. It is in fact being executed every time it gets used by one of its downstream queries. And we can use the diagnostic tools to see this. First, let's select our source indicators query, then select the source step from our recipe, go to the Tools tab, and click the button labeled Diagnose Step. This will cause Power Query to refresh the data and spit out a new set of queries grouped under this folder on the left-hand panel called Diagnostics. These queries show us the results of the diagnostics we just ran, and notice how each of these queries is italicized, which means that they are deactivated. Those queries won't be loaded into Power BI Desktop, so we can just look at them here in Power Query. The first of these contains detailed diagnostics, and the second one contains aggregated or summarized diagnostics. The summarized view just collapses multiple related operations into a single operation, resulting in fewer rows in the diagnostic output. If we look at the detailed query, we see that it shows us the name of the query, the name of the step, and then each row that represents an operation occurring as part of that query step. In this case, if we look at our source step, we see there are several things happening, and of particular note is this read file operation occurring on row 6, and if we go to the right, we can see the path of our CSV file contained in the resource column. Now let's go to our source land area query, select the source step again, and then once more click Diagnose Step. We'll get another set of diagnostic queries, and if we click on the one called Source Land Area Source Detailed, we can once again find the read file operation and find our CSV file path located here on line 6. So this would seem to vindicate what I said in that earlier video, that referencing a query doesn't cause it to execute only once. In fact, that query will be executed by each downstream query that uses it. Here, we can see that in action, as our downstream query is calling that CSV file to retrieve the data from it. Now, what we don't readily see here are the other operations that happened upstream, such as the unpivoting of the data, but these are happening as well in these other operations that occur on the source step. Now suppose that we want to get diagnostics for our entire Power Query refresh process. To do that, we can return to the Tools tab, click the button to Start Diagnostics, then we can go to our Home tab, open the Refresh menu, and select the option to Refresh All. Once the refreshes are complete, we can then go back to the Tools tab and say Stop Diagnostics. Once we've clicked Stop Diagnostics, we'll see 3 more queries visible here in our left-hand panel, such as Diagnostics Counters, Diagnostics Detailed, and Diagnostics Aggregated. We can use these to explore the diagnostic results across all of our queries. So as you can see, query diagnostics are a helpful tool for troubleshooting performance in Power Query. We won't really cover this topic in any more detail in this course, but I'll include some reading below this video for those who want to learn more. Earlier in this course, we talked about the fact that Power BI projects consist of 2 layers, a dataset layer and a report layer. Power Query loads the dataset from one or more data sources, and that dataset, also known as a tabular model, is then queried by our Power BI report using the DAX language. In years past, it was very hard to separate the dataset layer from the report layer in Power BI. The PBIX file format that we've been using in this course compiles everything together into a single file. This has the advantage of making our Power BI projects nice and portable. If we need to share a dataset and report with someone, we can just email the PBIX file to them, or upload it to a site, or publish it to the Power BI cloud. However, there are several disadvantages to PBIX files. For one thing, remember the fact that if your dataset is running in import mode, the dataset physically contains the data that Power Query copies from the data source. That means the dataset travels with the PBIX file. This poses 2 main issues. The first issue is size. The more data in your dataset, the larger your PBIX file will be when it is stored on disk. Although Analysis Services does a good job of compressing the data in the dataset, it can only do so much. And since Power BI has such impressive storage capacity, you can have PBIX files that are hundreds of megabytes in size, or even several gigabytes. Once they get to be that size, they become far less portable. For instance, it becomes virtually impossible to send them over email, and you may even have trouble uploading them to cloud-based storage. You may want to find a way to move the report and data model without bringing the data physically along with it, and that's pretty much impossible to do with a PBIX file. The other issue posed by the dataset being bundled with the report is data security. Some Power BI datasets can contain confidential or proprietary information that you don't want exposed. People's identifying information, their contact information, or company secrets that could be useful to your competition. These are all things that could end up in a Power BI dataset, and you always want to minimize the chances of someone intercepting and seeing that data. Under data protection regulations like GDPR, HIPAA, and so forth, data breach violations can cost your organization millions of dollars, and a PBIX file is a potential way for malicious actors to acquire your data. So, sending a PBIX file over an unencrypted email or an unsecured file share could be a very bad idea, unless you can find a way to strip out the data that is physically stored in the dataset. Another big disadvantage of working with PBIX files is they are not compatible with version control systems. Software developers across the world use version control systems like Git, Subversion, and Mercurial to work on application code, configuration files, and other components of software systems, because those version control systems allow us to carefully track and approve changes to our applications. This makes it easier to determine the root cause if something breaks, or if we simply need to find out who changed some code and why they changed it. A version control system like the one you see here in Microsoft Azure DevOps can even show you exactly which lines of code changed. However, this kind of change tracking was impossible with Power BI until just recently, because PBIX files did not allow for it. Now, one way developers found to get around the size and data security issues with PBIX files was to save their reports as Power BI template files, or PBIT files. PBIT files don't contain any data. They just have the data model definition and the report definition. This allows the PBIT file to be shared with others without any risk of compromising your data. Then, when the other person receives the PBIT file, they simply need to connect to the data source and load in the data. However, while PBIT files can solve the size and data security issues, they don't solve the version control issue. Neither PBIT nor PBIX files or PBIX files can be interpreted by a standard version control system. You can absolutely upload them to a version control platform like GitHub or Azure DevOps, but you can't get the benefit of the sort of line-by-line change tracking like you see here, because pbix and pbit files are stored in a binary file format that these systems cannot interpret in this way. Now, for hobbyists and small teams, issues like size, data security, and lack of version control may not be a big deal, but for enterprise teams at large organizations, or even just smaller teams who work with sensitive data, this has long been a very frustrating aspect of working with Power BI. Over the years, independent developers have had to come up with some solutions, but Microsoft themselves didn't really give us any good options to deal with these concerns until just recently. In the summer of 2023, Microsoft released a new method for saving your work from Power BI Desktop. It's known as the Power BI Project Format, or PBIP for short. In Power BI Desktop, when you save the report you're working on in the PBIP format, the application will break the project down into a hierarchy of folders, subfolders, and files that logically organizes all of your Power BI assets in one place and in a file format that makes it much easier to track changes using a version control system. Not only that, but it takes the data that is physically stored in your dataset and saves it into a separate data cache file that you can tell your version control systems to ignore, which means you can actually separate the data itself from the model and the report. Let's explore how to work with Power BI projects now. First of all, open your settings and make sure that under the preview features, the option for Power BI Project or PBIP is enabled, unless the feature is already generally available, at which point you can ignore this. Then let's go to File, Save As, then pick a folder, make sure that you've selected the PBIP file type from the drop-down menu, and click Save. Once it's done saving, open up your Windows File Explorer and let's take a look at what we've got. In the file folder, the first thing you'll notice are two subfolders, one named Dataset and one named Report. Then we have a gitignore file here and a pbip file here. Let's start with the Dataset folder. If we double-click on this, we'll find several files, and the one that I want to focus on is this model.bim file right here. I'm going to go ahead and open this in VS Code, so we can take a look. If you think that the language inside this model.bim file looks a lot like JSON, well, you're right. It's a JSON derivative known as TMSL, or Tabular Model Scripting Language, also known as TMSL, and it very strongly resembles JSON. This model.bim file contains all of the metadata about our Power BI data model, including our Power Query recipes, table definitions and relationships, and our measures. If we scroll down far enough, here you'll see our Power Query M code for each of our queries. And if we scroll down even further to the very bottom, we'll also find our DAX measures. Now I'm going to return to our folder and I will open up this PBI subfolder where you'll see a file named cache.abf. This is the data cache. This holds the data that we copied from the data source into our data model. If the cache.abf file is available inside of this folder structure, whenever we open up the pbip file here, then we'll be able to load the project with the data carried along with it. However, if we open up this gitignore file, we'll see that it has an option saying pbi/cache.abf. This gitignore file is used in Git-based version control systems to tell a version control system what files to ignore. In other words, if I load this into GitHub or Azure DevOps or another Git-based version control system, that system will not load the cache file. This prevents us from accidentally loading sensitive data or very large data models into a version control system where we'll either be exposing potentially confidential data or we'll be burdening the version control system with a large file that it may not be able to handle. Next, let's go back to the folder structure, and this time let's open up the report subfolder. Within here, we can see several more files, and the one I want to focus on is this report.json file here. And this actually contains the various definitions of the report itself. Within the report.json file, we see a bunch of stuff here that we may not understand, but if we scroll down a little bit further, we can also see these arrays which contain x, y, and z coordinates, as well as height and width. What you're looking at here are the dimensions and locations of our various charts and visuals inside of the Power BI report. Now, if we go back to our folder, we can open up static resources and look at registered resources, where we'll find a bunch of the images that we uploaded, as well as the GeoJSON file that contains our data for the shape map visual. Now, with all of this in mind, let's explore how you can track changes to a Power BI project using a version control system like Git. In this demonstration, I'm going to use SourceTree, which is a free Git client that you can download for Mac or Windows, seen here. First of all, I'm going to return to Power BI Desktop, and then I'm going to grab our button navigator here, and I'm just going to move it down a little bit on the page. That's the first change I'm going to make, and then I'll find a measure that I want to modify. Find GDP annual growth, and I'll come in here and I'll add another comment, which says maybe December 12th, 2023, Beth fixed more of Pete's mistakes. Then I'll commit that and save our file. Now let's go back to SourceTree and see what it looks like here. In this bottom left panel, we can see both of the files of our Power BI project that were changed. First, we'll look at model.bim, where we can see that our DAX formula has been updated on line 3718 to include the text where Beth fixed more of Pete's mistakes. Then, if we go to report.json, we can see where the y coordinates of one of our visuals was changed. It went from 8 to 32, which basically represents how I took the button navigator and just moved it down in the page a few spots. For the next part of this demonstration, I'm going to close Power BI Desktop for a moment. Then I'm going to go back to our folder and find the pbip file. Now, if I reopen the project as it is right now with the cache.abf file still in the subfolder, we should still be able to see all of our data inside the report. Now that it's done opening, we can look around and see all of our data is right where it should be. But now let's close the file, go back into our data set, find the PBI subfolder, and delete cache.abf. Then let's go back to the pbip folder and open the pbip file one more time. Now, when the file is done loading but the cache.abf file is not present, we can see that no data has been loaded into the report. In fact, we get a yellow banner at the top of the screen that says some of the tables have incomplete or no data. If we go to the data view, we can see that this is indeed true. There's a little button on this banner here that allows us to refresh now. So if we go ahead and click that, it should query our CSV files and APIs and bring in everything that we need to complete our report. And there you go. And the reason I wanted to show you that is because if you suppose a different developer on your team needs to work on the same Power BI report that you're working on, you may have uploaded your project to GitHub or another version control system that your team is using, and that other developer may have downloaded the project from there. So I wanted to show you what the experience would look like for them. If they don't have that cache.abf file, because the gitignore file caused it to not be loaded into your Git repository, then when they download the pbip project from the repository, that's the experience they'll see. They'll just need to refresh the data. I won't go any deeper than this into the topic of version control systems because I know not everyone taking this course is a software developer, but for those of you who are, this should hopefully give you enough information to get started building your own Power BI repositories in GitHub, Azure DevOps, or whatever platform you use. For everyone else, this video at least should help illustrate a little better what Power BI looks like behind the scenes. Familiarizing yourself with the underlying architecture of your Power BI projects is an important aspect of understanding how all of this technology works together, and it will equip you for success as a Power BI developer. In our last lesson, we talked about Power BI projects and how they allow us to see what our models and reports actually look like, especially thanks to the model.bim file that shows us our tabular model definition using the TMDL language. Now, if you looked at the TMDL language and thought to yourself that it looks pretty hard to read in some places, you're not alone. Especially when you're looking at Power Query and DAX formulas, TMDL can make it difficult to interpret what's going on because you have a lot of quotation marks and extra characters in there that don't really resemble the formulas that we wrote inside Power BI Desktop and Power Query. Recently, some Power BI developers took it upon themselves to develop a new language that can convert a Power BI tabular model's metadata into a more readable format. They call this new language TMDL, TMDL, or the Tabular Model Definition Language. Their work was so revolutionary and well received by the Power BI community that Microsoft is going to begin officially supporting TMDL, so I want to use this video to show you what TMDL looks like. As of now, in July 2023, there are really only one or two ways to extract TMDL from a Power BI report. There will soon be a new extension in Visual Studio Code, as well as probably some options in Power BI Desktop, but for now, I will have to resort to using an external tool called Tabular Editor. Tabular Editor is the best tool for working with just the data model portion of a Power BI project. It doesn't look like much, just a basic Windows form application, but it allows you to modify any part of a Power BI tabular model, including some features that you may not be aware of because Power BI Desktop currently doesn't give you a way to work with them. One such feature is known as calculation groups, which is an advanced method for working with groups of DAX formulas. Another feature, as of the moment I'm recording this, is TMDL. Now, Tabular Editor currently has two versions available. Tabular Editor 3 is the latest and greatest version with tons of awesome features, but you have to pay to get a license for it. However, Tabular Editor version 2 is available for download from GitHub, and it's 100% free. It doesn't have as many features as Tabular Editor version 3, but it can still do most everything you need it to do when working with your tabular models in Power BI. For this demonstration, I'll be using Tabular Editor version 2, and I'll include a link below this lesson so you can download it as well if you'd like. Once Tabular Editor is installed in Windows, it should automatically show up in your External Tools tab in Power BI Desktop, alongside DAX Studio, which we used a few lessons ago. To open your Power BI model in Tabular Editor, just have the model open in Power BI Desktop, then click the button for Tabular Editor. Once Tabular Editor is open, in order to export everything into a TMDL format, you need to go to File, then Preferences, and on the Serialization tab, you need to make sure that the serialization mode is set to TMDL, which as of the current moment that I'm recording this video, is still in preview. Then click OK, and when you're ready, go to File and Save to Folder. All you need to do now is pick where you want to save your TMDL files, then select, and Power BI will take care of the rest. Within File Explorer, you should be able to see the structure of the TMDL export. We have one subfolder named Cultures and another named Tables, and then we have three TMD files named Expressions, Model, and Relationships. Let's open the Expressions TMDL file first to take a look at it. Once we've opened the Expressions TMDL file inside a program like Visual Studio Code, we can see that it contains some of our queries from Power Query. Specifically, it contains all of the queries that are deactivated, like source indicators and source countries. Now, when we compare how this looks compared to how the model.bim file looked, you can see that this is a lot cleaner and a lot easier to read because there aren't as many extra characters. We don't have extra quotation marks and so on that are sort of making this more difficult to read. Instead, this is a very easy plain text format that's really, really simple. Furthermore, if we go back and go to the tables folder and then open up a table like countries.tmdl, we'll also see that this contains all of the metadata about the columns inside of our countries table. This includes, as you can see from lines 5 to 12, the Power Query M code that is used to generate this table from our source countries query as seen on line 9. Now let's see what this looks like inside of source tree. I've got my TMDL files up in source tree, and it's picked up the changes that I made, particularly down here in the bottom right corner, where you can see the comment that we added saying Beth fixed more of Pete's mistakes. One of the nice things that I really like about TMDL as opposed to the TMZL format is that TMDL breaks everything down into more files. Instead of having one large monolithic model.bim file, we actually have several different files, including one for each table in our model, like measures, countries, indicators, and metadata, as well as this expressions file, which contains all of the information about the Power Query code that is used to generate those tables. So hopefully you can see how TMDL is a much more concise and readable format compared to TMSL. Whereas TMSL appears very similar to JSON, TMDL is more reminiscent of YAML, which is a language you might be familiar with if you're a software developer who has dabbled in the world of DevOps engineering. I personally think that this is way easier to read, and I'm really looking forward to Microsoft providing more support in the future for TMDL, as this will make it a lot easier to integrate Power BI projects into version control systems like we covered in our last video. Beyond using TMDL, I highly recommend that every Power BI developer download Tabular Editor and explore how to use it. You won't always need it for your Power BI projects, but it provides a lot of benefits compared to editing your model inside of Power BI Desktop, especially once you get into more advanced data modeling scenarios. Of course, we won't cover those scenarios in this course, but I still wanted to take this opportunity to introduce you to Tabular Editor, because it is a must-have tool for the serious Power BI professional.
Welcome to the final exercise for week 2. Same as week 1, you will be asked to complete this exercise on your own, but I'll give you some hints because this exercise might be a little tricky, especially on the visualization side. You'll be adding some new data to our global economics report, and this data comes to us directly from NASA, the National Aeronautics and Space Administration, here in the United States. NASA does a lot more than put astronauts on the moon so they can play golf and drive dune buggies. They also dedicate a lot of their resources cataloging and analyzing data related to what they call the vital signs of the planet, which refers to several environmental indicators such as global temperature, atmospheric carbon dioxide levels, and sea levels. For this week's final exercise, we'll be looking at NASA's vital signs data related to global temperature. Specifically, the data we'll be adding contains yearly measurements of the change in global surface temperatures compared to the long-term average from 1951 to 1980. So the data we're looking at represents the change in surface temperatures relative to that baseline average from 1951 to 1980. And it paints a dramatic picture of just how much global temperatures have increased in the last 50 years. The goal of this exercise is to visualize the relationship between economic output and global temperature changes. The chart you're building should look something like this. This is known as a scatter chart, and you've almost certainly seen it before because it's probably the most commonly used data visualization when we want to show the relationship between two variables. This is going to require several steps to complete. First, adding NASA's data in Power Query. Second, transforming some of that data in Power Query, then making some changes to our data model, and lastly, adding a new visualization to our report that tries to show that relationship. Some of the things that you need to do in this exercise translate directly into topics that we'll cover in week 3. The main thing you'll need to do is use Power Query to create a new table that contains only a list of years at a granularity of 1 row per year, from the first year of our indicators to the last year of our indicators. In other words, if we have 50 years worth of data in our data set, this new table you're creating should be 50 rows in length, with each row containing a distinct year. This table will go into our data model and will serve as a key component for us to visualize both the GDP indicator from the World Bank and this new temperature data from NASA. To do this, all you need to do is go to your indicators query, find that year column, right-click on it, and select the option to Add as New Query. Then you'll need to look for a function that allows you to remove duplicates from a column and another function that allows you to convert lists into tables. This may require you to explore Power Query a bit and perform some trial and error with your recipe. But if you can figure out these two things, then you'll just need to merge the year data with the NASA temperature data so that you have a temperature reading for each of those 50 years. At that point, you'll be done with Power Query. After that, you'll want to add a relationship in your data model from the new year table to the indicators table, and you'll probably want to create a measure that sums the global temperature change, and both of these tasks should be simple for you by this point. For visualizing the data, you have one of two options. You can add the scatter chart to the overview page, or you can add it to the country detail page. It doesn't matter which one you choose, although whichever one you choose may require you to remove one of your other charts in order to make room on the page. If you add it to the overview page, you will get more interactivity with this chart because you'll have more ways to cross-filter and cross-highlight it using your other visuals. Okay, hopefully those hints are enough to get you started. You'll get some quiz questions that test your ability to complete this exercise, and then I'll walk you through how I solved this. All right, rock stars, let me show you how to complete the Week 2 final exercise. We will start by going to Get Data from Text or CSV, go to your Week 2 files, and find the file named NASA Global Temp Data.csv. Once you're connected, go ahead and hit that Transform Data button to load up Power Query. And once we're in there, we can actually see there's very little that needs to be done with this data. The data types are already set. We've got years, and we've got this temperature column, which measures the temperature in Celsius. So what we really need to do here is we need to create a new table in our model that is one row per year. To do that, we're going to go to Indicators, select our year column, and then right-click and say Add as New Query. We will then remove duplicates and convert this into a table. Go ahead and click OK. I will sort in ascending order, like so. And then, in order to add the temperature data, I will merge queries and select the NASA Global Temp Data table, joining column 1 on year using a left outer join. Click OK. Once the tables are joined, click the Expand button, and let's add the temperature column. While we're here, let's go ahead and update the data type on our year column to make it a whole number, and then rename it as year. Finally, we'll go back to our NASA Global Temp Data query, right-click, and deselect the Enable Load option. I will then move it up into this query group here called Source Queries, so it's with the rest of our deactivated source queries. At this point, I've done everything that I need to do inside of Power Query, so I'll click Close and Apply. And once it's done loading, we'll go to the Model view and make sure that we have a relationship from the year table to the indicators table based on that year column. And we do. Power BI helped us out and created that relationship automatically. Now we need to add a measure that sums the temp C column. So I will go to our measures table, click New Measure, and we will call this one temperature equals sum of temp C, close parenthesis, and commit. Looks like it accidentally added it to our countries table. I don't know why. So I'm going to change the home table to measures and get it in the right place. Now, if we go back to our report canvas, we're ready to plot this data. First, I need to clear a little space, so I'm actually going to get rid of our map visual, and now I will add a scatter plot. Go to the menu, find the scatter chart, drop it in there, and then let's get it relatively aligned to our little container here from PowerPoint, and now we can start adding some fields to it. In the values section, we will go to our year table and we'll add year. Then on the x-axis, we'll add our GDP measure, and on the y-axis, we will add the temperature measure. Now we need to give our chart a really good name, so I'm going to go to the Format Settings, find the title bar, and I've got a really good title I want to use. It sounds very scientific. I'm going to paste it in here so that you can see it and replicate it on your own. We'll put it up on the screen for you, but it says relationship between GDP and constant 2015 US dollars and global temperature change relative to the 1951 to 1980 average measured in Celsius. That is a very, very long title, but it's also extremely helpful and descriptive. I'm just going to maybe put the font size down a little bit so it doesn't take up as much space. And I think that looks really good. The next thing we can do is enable some data labels. So let's go to our chart and turn on category labels. And it looks okay. We've got a lot of points here, and it looks like it wants to add a label for every single one.
but that's okay. If we look at our chart, we can definitely see how the later years in our data seem to correspond to an increase in temperature. We see more GDP over time, we see higher temperatures over time, and we can cross-highlight some of this. So this chart gives us a sense of the relationship between GDP, which is economic output, and global temperature changes. As countries have been more economically active in the last 50 years, global temperatures relative to that 1951 to 1980 baseline have steadily increased. And that's it for this exercise. This may have required a little bit more experimentation, a little more trial and error, because I gave you fewer hints on how to complete it. But hopefully you still found the end result without too much trouble.